Volcanic eruptions are one of the most powerful forces on Earth. From spectacular lava fountains to deadly explosions, they can bury entire cities under superheated clouds of ash and gas, or turn quiet rivers into seething torrents of mud and debris. Scientists are struggling to understand these unpredictable time bombs.
We were taken by surprise by what turned out to be an unprecedented event.
We'll circle the globe, profiling some of the most significant eruptions of our time, each more devastating than the last, each leading to a potential mega eruption that could change the world as we know it. Volcanic eruptions are dramatic reminders that our world is a living planet. Their destructive force is 4 billion years old, a force that commands respect. Volcanoes combine the beauty and the beast, the power to create and to destroy. From the very beginning, they've served a vital function, releasing heat, gas, and minerals from deep beneath the Earth's crust. These byproducts proved vital to human life, creating the Earth's atmosphere. If volcanoes did not exist, neither would we.
To me, they're one of the most beautiful things you can ever witness. But to the people who live under them, they're the most terrifying and destructive thing you can ever witness.
Cameraman Jeff Mackley's mission to film the world's volcanoes comes with risks. On one mountain, he avoided death by moments when a lethal mixture of hot gas and ash just missed him.
There was a loud roar like a freight train, and a pyroclastic flow came down the valley that we'd just been in. So, yeah, another 5 minutes either way, it would have been curtains for us.
Mackley risks his life to record volcanoes' beauty. Others risk theirs to record their power.
Many of us have experiences that could either have gone one way or the other, depending upon just something small that happened.
In the past 60 years, volcanic eruptions have killed at least 27 scientists. Even so, their quest for knowledge continues. On average, between 50 and 60 volcanoes erupt every year. About 20 are erupting at any given moment. All are vents in the Earth's surface. Most take place within the Ring of Fire, an area around the Pacific Basin where tectonic plates collide, allowing molten rock or magma to be released. Thick magma loaded with gas triggers explosive eruptions. Thinner magma with less gas is less volatile. To compare and categorize eruptions, scientists have developed the Volcanic Explosivity Index, or VEI scale. Each notch up the scale means a higher ash cloud, more ejected material, and greater explosive energy. The events profiled here begin with a non-explosive eruption and peak with a planet-altering super eruption, one that experts say will eventually happen. Hawaii is a stunning tropical paradise. But under the brilliant sand and lush forests simmers a cauldron of tremendous heat and violence. This is the site of one of the most spectacular volcanic creations on the planet. All of the Hawaiian Islands are volcanoes, built over 70 million years by a powerful geological formation called, appropriately, a hotspot.
A hotspot is a narrow zone which has an excess amount of heat in it. And the heat rises, and relatively near the Earth's surface, this heat melts the rocks, and then that melted rock erupts as lava.
February 1983. Kilauea, on the big island of Hawaii, sends lava fountains 80 meters into the air. Because Because the magma is thin and doesn't contain much gas, the eruption is not explosive, but it's still dangerous. For 7 years, the eruption continues. The lava inches forward, slow enough to outrun, but totally unstoppable. In February 1990, it reaches the fishing village of Kalapana. Hundreds are evacuated.
It became a very painful experience, actually, to watch this because it was just creeping through town, you know. Every week or so, another block's worth of houses were gone.
Residents have time to pack up their belongings and, in some cases, their entire homes. Others can only watch as the lava destroys their past.
We moved out that afternoon, and 2 days later, our home was engulfed by flames. And we were able to watch the lava come into our yard.
By December, the entire village is gone, buried under more than 15 meters of molten rock.
Behind me is the eastern edge of what used to be the town of Kalapana. In 1990, there were about 150 homes out here, and they've been buried by about 5 stories worth of lava.
Despite the hardships caused by the volcano, some Hawaiians see beyond their personal tragedy. They respect the power and the beauty of the lava, a force they worship as a goddess named Pele.
We don't really resent or feel like it was a loss for us, because we know that Pele, this is her land, her aina, and she can come anytime she wants to and go anywhere she wants to.
The Hawaiians were unable to stop Kilauea's enormous lava flow. But 4,800 kilometers away, an entire nation took a desperate stand when a volcano threatened one of their towns. On January 23, 1973, the Eldfell volcano erupts on the Icelandic island of Hime. A slow-moving lava flow more than 10 meters high threatens to engulf the village of Vestmannaeyjar. The majority of the village is evacuated, but a dedicated team stays behind to confront the formidable force. Over 5 months, crews spray approximately 6 million cubic meters of seawater onto the lava flows. Nearly 4 million cubic meters of molten lava is converted into solid rock. The village is saved. Such a Herculean effort is impossible with Kilauea. The flow is simply too great. The lava that destroyed Kalapana plows on, pouring into the sea in a spectacular collision.
Where the lava goes into the ocean, it makes one of probably the most beautiful places on the flow field, but it's also one of the most dangerous.
Below the solidifying lava, unstable sand is prone to sudden and violent collapse.
All of a sudden, all this hot lava is on the surface, it just snaps off. The ocean rushes in and it creates huge explosions that send gigantic plumes of material up in the air, and they cover maybe 3 or 4 football fields in area, sending out rocks the size of like soccer balls or basketballs all over the area.
This impressive display is a glimpse into prehistoric times when volcanoes first formed land. The same process is still happening today.
It builds new beaches, and then these beaches, the lava then can flow over, and it builds that out, a sequential set of beaches, and then lava flow and beach, lava flow, and it builds out a new piece of land that we call a lava delta.
Since 1983, Kilauea has displaced almost 200 families and destroyed millions of dollars worth of property. In that same time, it's added more than 200 hectares of land to the island, continuing the 70 million year process that created all of Hawaii. It's a stunning example of how a volcano creates and destroys at the same time. Its slowly oozing magma is a permanent threat, but rarely produces a violent explosion. In our next event, thicker magma trapped in a geological powder keg triggers a much more explosive volcanic eruption. Lethal white-hot clouds of gas descend on thousands of people, wiping out an entire Caribbean capital. And later, in our mega-disaster scenario, a supervolcano strikes the heart of Europe, demolishing a major city and casting a shadow over the entire planet. The stunning lava fountains and flows of Kilauea on the big island of Hawaii both create and destroy, but rarely are lethal. But there are much more explosive and dangerous volcanoes, ones that spew out deadly gas and ash clouds. One such volcano ravaged half a nation and sent 19 to their graves. Montserrat is a lush and tranquil Caribbean retreat. But in 1995, the Soufriere Hills volcano, quiet for nearly 400 years, rumbles back to life. Over the next 2 years, multiple eruptions shoot ash thousands of feet into the air. The capital of Plymouth is evacuated twice. Each time, the residents return, hoping the volcano's rage is over. On June 25th, 1997, those hopes are buried. At 1 p.m., a giant ash cloud erupts nearly 10 kilometers high. In the next 30 minutes, close to 800-degree mixtures of ash and rock race downhill at more than 100 kilometers an hour. The lethal clouds are called pyroclastic flows. Roy Daly lives 3 kilometers from the volcano. He hears the eruption and rushes outside to see the flow racing by him, less than 50 meters away.
Started to feel some heat, and the darkness started to roll over the road. So I got in my car and I sped away like crazy. I drove on top the hill, away from the pyroclastic flow.
The force of the thick mixture of gas, ash, and rocks flattens everything in its path. Roy watches helplessly as entire villages are destroyed. He's managed to escape the pyroclastic flows, but he's not out of danger yet.
I was scared to death. I thought I wasn't gonna live. It was so dark that if you put your hands to your face, you couldn't see them. Hot ash raining down on you, real hot ash. I felt scared. I couldn't move, I couldn't see, I couldn't breathe properly. So, of course, I felt I was gonna die. But I was hoping I didn't die, and I didn't.
Roy is finally evacuated by helicopter, but not everyone is able to escape. Dr. Sue Laughlin is the director of the Montserrat Volcano Observatory and a witness to the eruption.
The maximum speed of pyroclastic flows on that day could have been in excess of 150 miles per hour. Even though people saw it coming, there was very little they could do to make their escape.
The nearly 8 million cubic meters of flow covers thousands of square kilometers of land, damages or demolishes more than 100 homes, and destroys the island's only airport. Other than one ferry service, Montserrat is cut off from the rest of the world. But the volcano is not finished. Over the next 4 months, eruptions and pyroclastic flows continue to devastate the island.
We had over 70 explosions in 1 month. Sometimes there were 4 explosions a day. Each explosion generated a mushroom cloud which rose rapidly to great heights above the volcano. Each explosion generated pyroclastic flows which spread in all directions around the volcano. You can see behind me the impact on Gage's Mountain of surges as they came over the mountain during one of these explosions and singed and burned all the vegetation there.
The pyroclastic flow's toll on the island's natural resources is immense. The human toll is 19 lives. The cause of this violent and tragic eruption lies deep below the lush island. The same process that created this tropical paradise threatens to destroy it. Here, the North and South American tectonic plates collide with and plunge below the Caribbean plate in a process called subduction.
The subduction takes place at about 130 kilometers depth, that's about 80 miles below the surface of the Earth. As the plate goes down, parts of it melt, and this forms magma. And the magma works its way up to the surface over many thousands of years.
Unlike Kilauea, the Soufriere Hills volcano produces thick magma. Over thousands of years, it forms the classic steep volcanic cone called a stratovolcano. The magma contains a variety of gases, all under intense pressure. It slowly rises until it reaches the Earth's surface when the pressure is released. Just like a bottle of champagne, the gases suddenly expand and the volcano violently erupts. Thousands of kilometers away in Bari, Italy, scientists are studying Soufriere Hills' most lethal side effect.
The purpose of these experiments is to understand the dynamics of pyroclastic flows, so to be prepared for the next events.
Dr. Delino and his team load about 200 kilos of actual volcanic ash from Mount Vesuvius into a cylinder. Pressurized gas creates an explosion that ejects the ash. The volcanologists track the height, direction, and density of the ash with a variety of instruments and high-speed cameras. The models here are big enough to be accurately scaled up to actual events, something that could not be achieved in a lab. The experiments have determined that both the amount of magma and the force applied to it are critical in the creation of pyroclastic flows. Next, researchers will match the test with the topography of specific volcanoes. They'll then be able to pinpoint specific areas where pyroclastic flows are likely to strike. Local authorities can evacuate those areas prior to an eruption, potentially saving many lives. But tragically, for those in the path of stratovolcanoes like Soufriere Hills, pyroclastic flows and ashfall aren't the only threats. Every year, between 1,200 and 2,000 millimeters of rain fall on Montserrat. Heavy rains run down the channels created by the pyroclastic flows, transforming them into massive mudslides called lahars.
Most of this debris that we see around us is caused by lahars, washing all the pyroclastic flow debris further down the hill and progressively burying Plymouth under all this mud and boulders.
Lahars have buried so much of Plymouth that the city has been permanently abandoned. They were the volcano's final salvo in a brutal one-sided war. The Soufriere Hills volcano destroyed more than 1,000 homes, left more than half of the island uninhabitable, and destroyed the nation's capital. About 4,500 people remain on the once thriving island of 12,000.
It was sad to see people just having to go by droves out of Montserrat. But it was understandable because these people had lost their properties. It was a pure strength why I stayed here. I mean, you had no place to go, no place to live, with families and friends, being shacked up still in schools and churches. It was difficult and it was very sad.
But the volcano has also created new opportunities that have helped revitalize the island. Volcano-related tourism is rising. Roy Daly owns and operates a tour bus business.
People are anxious to see a live volcano. I don't think there's any place on the face of the earth that you could see a live volcano from approximately 1 mile from it bubbling and rolling and rocking, right?
Though Soufriere Hills' multiple pyroclastic flows and lahars were lethal and destructive, its eruptions never exceeded a 3 on the Volcanic Explosivity Index. But when a VEI-5 fires a single 24 megaton blast, it destroys thousands of acres of land and kills dozens of people. And later, scientists explore the potential for a super eruption, one unseen in modern times, one that could kill millions. The pyroclastic flows and lahars of the Soufriere Hills volcano on Montserrat destroyed the island's capital, killed 19, and changed the nation's landscape and thousands of lives forever. In 1980, America's Pacific Northwest experienced a different and rare type of eruption that acted like a giant cannon blast. flattening entire forests and killing dozens. The Cascades are an 1,100-kilometer-long majestic range stretching from Canada to Northern California. Hundreds of thousands of hikers and skiers find refuge and adventure here. But in the spring of 1980, one of the Cascades' crown jewels begins to fracture. In March, small earthquakes ripple deep below the peak of Mount St. Helens. After more than 120 years of slumber, the mountain is awakening.
This seismicity is typical of volcanoes when they reawaken, because as molten rock tries to push its way up underneath the volcano, it makes a lot of noise in terms of shouldering aside the hard rock that makes the edifice of the volcano itself.
On May 17, Keith Ronholm, a geophysics graduate student intrigued by the mountain's activity, decides to get a closer look.
Mount St. Helens was erupting about every 5 or 8 days. I had gone to a place called Bear Meadow to try to get a view of one of these small summit eruptions.
Ronholm gets far more than he bargained for. At 8:32 on the morning of May 18, a magnitude 5.1 earthquake rips through the volcano's north side. 2.8 billion cubic meters of earth falls at speeds of up to 257 kilometers an hour.
I was reading a book in my truck when I heard some people yelling, and I looked over at the mountain, and the entire north side of the mountain was sliding down.
The Earth's movement releases the enormous pressure holding the magma inside the volcano. A 24-megaton blast, over 1,800 times more powerful than the Hiroshima atomic bomb, shatters the north face of the mountain. The blast is unusual in that it doesn't shoot straight up as most eruptions do. This is a rare lateral blast, slamming a huge cloud of rocks, trees, and ash approximately 180 degrees out from the mountain.
There was a puff of dark gray churning ash, and within 10-15 seconds, that ash had expanded out and had covered the entire mountain. All of this was happening silently, and it was no noise to reinforce my flight response. I was 10 miles away, and you don't, at least initially, feel like something's going to hurt you from 10 miles away. So I stood there and I took pictures, and I was fascinated by watching this event.
As the huge cloud of debris races over the two ridges between the volcano and Ronholm at 483 kilometers an hour, Keith suddenly realizes he's in serious danger.
As I'm driving out, I took one last picture over my shoulder, and it's a little motion blurred, but I couldn't take time to frame it or stop because I was driving, and I remember looking back at the little parking area, realizing that I was the last person to leave and thinking maybe I'd waited a little bit too long because this cloud was rushing towards me.
Luckily for Ronholm, the strongest part of the blast heads north and northwest. The portion that's heading northeast, directly towards him, has less energy, allowing him to escape down the mountain. The lateral blast spews ash and gas up to a height of 24 kilometers. Less than an hour later, a vertical eruption sends more ash skyward. Into this grim scene flies Jess Hageman with the Washington Army National Guard.
Most of the trees were blown over by the eruption, and we're talking about 14, 15 miles downstream of Mount St. Helens. The whole landscape was changed. It made you feel like sort of a gnat flying around the universe, because in comparison to the size of the eruption, it was amazing.
Amazing and horrific. 800-degree pyroclastic flows race down the steep flanks at up to 129 kilometers an hour. In some places, they are 37 meters thick. In the early hours of the disaster, the enormity of the destruction to the landscape is impossible to comprehend. But it only takes one sobering moment for Jess Hageman to realize the human toll.
It was on this ridge right straight ahead of us here that we found the first 2 survivors in the blast area. And that turned out to be Jim Skamanki and his partner, Leonti Skurkadov. And we eventually were able to pick those 2 people up. Leonti died in the hospital after we got him there, but Jim is still alive and survived.
Rescuers find a handful of stunned survivors, but the eruption kills 57, mostly campers and tourists. 9 hours after its start, the eruption ends. Scientists struggle to comprehend the enormous scope of the event. Before the eruption, Mount St. Helens stood at 2,949 meters tall. Now, it's 401 meters shorter. The blast destroyed enough trees to build 300,000 houses. Thousands of logs still litter Spirit Lake, 5 kilometers from the summit. The volcano shot out more than 508 million tons of ash that spread across the entire US in 3 days. 2 days after the eruption, geologists get their first close look at the desolation.
It was like walking on the moon. I have never seen anything like it. This entire area, which is 600 square kilometers or 230 square miles, was totally devastated. There wasn't a living thing in that entire area, not an insect or a bird or an animal. There was only one color, and it was this gray color of the deposits. The ground was covered with hot rocks, and there were fumes and hot gases coming out of the ground all over the place.
In the months following the eruption, teams of experts carefully study every facet of the mountain. One oddity of Mount St. Helens was that some people heard the eruption as far away as Canada, but eyewitnesses like Keith Ronholm, just 16 kilometers away, heard nothing.
Because of the way the temperature structure in the atmosphere gets cooler with height, that the sound waves from explosions are bent away from the surface of the Earth. And when they reach the stratosphere and the temperature again increases with height, they're bent back down. So no one between 6 and 60 miles from Mount St. Helens heard the May 18th eruption.
Since 1980, the mountain has experienced tens of thousands of small earthquakes and numerous minor eruptions. Most significantly, since 2004, the volcano has been continuously erupting lava, creating a giant lava dome that is still growing today. It's volcanologists like Rick Lahusen's job to find ways to monitor all of this activity.
What we needed was a way to get our instruments out there very quickly without putting people on the ground in harm's way, and yet still be able to monitor changes in the eruption. So what we came up with is this stainless steel superstructure, which kind of looks like a daddy long-legged spider, so we kind of call them spiders. This is a GPS antenna which receives timing signals from satellites and lets us locate exactly where this is. The signals go into the computer system, and then the data come out at the request from computers back in the office and are transmitted out through this antenna.
With the spider securely attached to a chopper, it's time to head into the belly of the beast. As they approach the crater, the new lava dome is visible, spewing out sulfur dioxide gas and steam. This is proof that magma is reaching the surface with the potential to build to another eruption. The most dangerous moment for Rick and his pilot comes as they place the spider on the lava dome. This close to the crater floor, exploding rocks or a sudden burst of steam could easily kill them. Operating with the precision of surgeons, the men carefully place the spider directly on top of the lava dome. Within seconds, the device begins gathering and transmitting data. At the Cascades Volcano Observatory in Vancouver, Washington, Lahusen analyzes the spider's digital camera images. Time-lapse photography shows the lava dome's formidable growth.
What's really phenomenal about this is how much rock is coming out of the ground. It's taller than the Empire State Building. It's coming up at 5 meters per day, more than 200 meters across, and it's right here in our backyard.
No conclusions have been drawn yet about the lava dome's rapid growth. Geologists warn that an eruption similar to the 1980 event is possible, but unlikely. They are certain, however, that future eruptions of some sort will occur. Whatever its future, the mountain's recent past continues to reverberate today, especially for those who were there.
It's just an amazing event to witness that we normally think of the Earth as being a very static, stable environment that doesn't change. But when you get to watch a volcanic eruption and you watch a giant piece of the Earth slide away, followed by this dynamic, churning ash cloud that flattens tens of square miles of forest, you realize how powerful nature can be and how powerful geologic forces can be.
Mount St. Helens VEI-5 lateral blast destroyed a massive amount of land and killed 57 people. Just one notch up the scale, a VEI-6 volcano kills hundreds when its huge eruption is followed by a long series of deadly side effects. And later, scientists reveal the unthinkable effects of a mega eruption that they guarantee will happen sometime in the future. The VEI-5 lateral blast eruption at Mount St. Helens flattened 600 square kilometers of land and killed 57 people. But there's one volcano that's in a class by itself. It killed hundreds, afflicted millions, and affected the entire planet. Its eruption was just the first in a series of tragic events that went on for days, months, and years that continue to this day. Luzon is the largest of the Philippine islands. It's home to 56 million people, the capital city of Manila, and Mount Pinatubo. For centuries, thousands have lived on and around the mountain. Farmers harvest rice and other crops from its fertile soil. What many locals didn't know or believe is that the mountain is a volcano. Even most experts who knew it was thought it was inactive. On June 9, 1991, the mountain erupts for the first time in more than 500 years. Eruptions, earthquakes, pyroclastic flows, and ash batter the island day and night. Geologist Dr. Kelvin Rodolfo arrives 4 days later.
The amount of ash was falling so thickly you couldn't see any more than 20 feet. There were pieces the size of chicken eggs that were landing on us.
On June 15th, a massive eruption spews 5 cubic kilometers of volcanic debris 35 kilometers high. The top of the mountain collapses, triggering a series of large earthquakes. Rodolfo is one of thousands trapped in the city of Olongapo, 33 kilometers from Pinatubo.
I was terrified continually during the eruption. Every 3 minutes or so, there was a noticeable tremor, one of the magnitude that would cause you impulsively to want to run outside of a building.
But outside, the scene is equally terrifying.
Reddish lightning was darting horizontally above people. And the claps of thunder were practically simultaneous with the lightning.
This intracloud lightning is caused by static electricity in the ash cloud. It's seldom dangerous because it strikes horizontally instead of vertically. Still, fear of the conditions outside stops many locals from sweeping the ash off their roofs, something that will have fatal consequences. On the same day as the eruption, a typhoon strikes Luzon. The heavy rains mix with the ash. Since ash consists of fine particles of rock and minerals, Adding water turns it into a cement-like substance. For those with several centimeters of ash on their roofs, the mixture is a deadly one.
The passing typhoon saturated the ash with water, making it a lot heavier, causing roofs to fall in and pull the walls of houses in after them.
As if that isn't enough, vast pyroclastic flows fill the valleys around Pinatubo with debris. Once again, the typhoon turns a volcanic byproduct into a lethal weapon, lahars. Lahars form when a large amount of debris rapidly mixes with a huge amount of water. The powerful mass churns downstream, destroying anything and anyone unlucky enough to be caught in their path.
If you imagine a bulldozer traveling perhaps 15 miles per hour, hitting the substructure of a bridge, the bridge is taken out, and that's the impact that large rafted boulders had.
After 9 nightmarish hours, the eruptions end. More than 300 people are dead, and tens of thousands are homeless. As bad as things are, they could have been much worse. In the months prior to the eruption, locals reported seismic activity. Ongoing scientific monitoring confirmed the reports. Guided by experts who pointed out specific high-risk zones, officials evacuated more than 58,000 people in the days and hours leading up to the eruption.
Prior to the eruption, we had made maps that anticipated where the tephra would fall, and that depended on the seasonal winds.
But in still another deadly development, the typhoon changed the wind direction. Areas that had been considered safe were inundated with a deadly mix of tephra, or ash, and rain that crushed homes and the people in them. As thousands begin the massive cleanup, the volcano's effects become global. 1 month after the eruption, the huge ash cloud circles the Earth. In the upper atmosphere, sulfur dioxide is converted into sulfuric acid aerosols. They reflect the sun's radiation away from the Earth, cooling the entire planet's surface by 1 degree. The effects on the Earth's atmosphere will last more than 2 years. Back in the Philippines, the volcano's after effects continue. In the 3 months following the eruption, heavy rains trigger more than 200 lahars.
As time progressed and the flows eroded deeper and deeper into the lahars, the channels got larger and larger and became much more efficient conduits for the slurries to flow down.
To help the hundreds of thousands of people in harm's way, lookouts are stationed upriver. When they sight a lahar, they radio priests like Father Nestor Tayeg, who ring their church bells in warning.
The bell sounds would be heard by the community any time of the night like an alarm, a warning. Warning, be prepared, lahar is coming.
But once again, a twist of fate conspires against the people of Luzon. In October 1995, another large typhoon strikes the island and lookouts are put on alert.
Unfortunately, the heavy rains that triggered the lahars were not yet loaded with sediment when they passed this watch point.
Consequently, the lookouts radio that nothing but floodwater is coming down the mountain. But as the water runs down the channel, it erodes a lot of loose material, bulking up the lahar into a mixture estimated at 80% sediment and only 20% water. The larger the percentage of sediment, the faster and more powerful the lahar. It strikes with incredible force.
It was making this noise, this sound, just like rampaging horses. It was coming closer. Suddenly, it invaded our parish church. The second floor of my rectory where I live was buried, and I climbed on top of the bell tower. The lahar still kept coming. You can actually hear the lahar still rising, burying the second floors of most houses. You can hear people screaming. It was very dark. You can't see a thing.
The lahar kills dozens and buries the entire town of Bacolor. Like cement, the remains of the lahar dry quickly and turn rock hard. Today, the entire village is built on top of the dried-out Lahar. Eerie reminders of the devastation are everywhere, including Father Ness's church, where a new floor had to be built over 7 meters of mud. Since 1991, thousands of Lahars have killed nearly 400 people and destroyed more than 42,000 homes. But scientists fear that Pinatubo is still not finished. On top of the mountain, a new threat is forming. Not magma, but years of heavy rainfall that have created a giant lake in the volcano's caldera. It breached its banks in 2002, generating a massive lahar. Geologists are concerned about a huge fault that runs through the area.
The rocks weakened by the fault are more easily eroded, and the walls of the channel are very steep, and so landslides could fall and plug the channel and cause the lake level to rise again and then spontaneously flush out in large amounts. That would generate new large lahars.
The lake contains 100 million cubic meters of water. 46,000 people live below it. All would be threatened by a major lahar. To date, the eruption and lahars have affected almost 2 million people. For the battered but resilient residents of Luzon, Pinatubo is a constant threat. For scientists, it's an ongoing spectacle.
In geological training, we are accustomed to thinking in terms of small events repeated over millions, tens of millions, or even hundreds of millions of years to generate mountains. But here we see events happening within a day. A huge amount of pyroclastic material, a huge hole developed over a matter of hours or days. And that, to me, is very fascinating.
The devastating byproducts of the Pinatubo eruption had long-term effects that killed hundreds, effects that continue to this day. But a mega eruption, one that volcanologists are certain will happen, could threaten millions. The VEI-6 eruption of Mount Pinatubo and its after-effects killed more than 700, sent a huge ash and gas cloud around the globe, and lowered the Earth's surface temperature. If we were to experience a VEI-7 super eruption, it would be 10 times larger. It would destroy all life for dozens of kilometers. It would drastically change the Earth's climate, and scientists say it will happen someday. The 5 million people in the Naples, Italy area live in the highest volcanic risk zone in the world. Approximately 11 kilometers to the east is Mount Vesuvius. Its 79 AD eruption killed more than 20,000 in Pompeii and other villages. Since then, the volcano has erupted 50 times, most recently in 1944. Vesuvius looms over Naples as a constant threat. But 15 kilometers to the west is a far less conspicuous but potentially far more deadly volcano, Campi Flegrei. Campi Flegrei is an enormous 13-kilometer wide caldera with a series of craters scattered inside. 350,000 people actually live within the caldera walls. Since Campi Flegrei is not a tall, imposing volcano like Vesuvius, it attracts little attention. But volcanologists like Steve Self know the massive power it contains.
Here we are in the middle of a volcano that's got a remarkable history of eruptions since it was first formed about 35,000 years ago. This area has had repeated eruptions, forming the craters like the one we're in. We're in a volcanic crater that still has steam vents acting and hissing, as you can hear behind us.
These steam vents reach temperatures of nearly 700 degrees. To a casual observer, that's impressive. But to experts, the vents, along with ground shifts, are ominous warning signs. An indicator of Campiflagre's power lies in deposits left by a massive eruption 35 to 40,000 years ago. It was 10,000 times larger than the 1991 Pinatubo eruption. These 80-meter-tall cliffs in Sorrento, 30 kilometers from Campiflagre, are composed of volcanic material left from the super eruption. Volcanologist Giuseppe Mastrolorenzo knows they are geological proof that enormous pyroclastic flows swept through this entire area.
The pyroclastic flow moved this way as a turbulent cloud and then emplaced en masse, thus causing the burying of all the area around Naples.
What scientists know about Campiflagre's past gives them a realistic model of what could happen in its future. The scenario begins with a massive disturbance somewhere within the vast caldera. A super eruption. More than 242 cubic kilometers of dust, gas, and pumice hurtle into the air.
It would bury very large areas, the size of a major city or more, in thicknesses of ash that are hundreds of feet thick.
Enormous pyroclastic flows race from the volcano at near supersonic speeds. Buildings that aren't already buried by ash are knocked down by the force of the flows, or incinerated by their 800-degree temperatures. The once proud city is completely annihilated. The death toll from the flows and ash is apocalyptic.
We can assume that in case of a super eruption, several million of people will be killed.
The casualties and destruction spread far beyond the immediate area. The eruption column grows to a staggering height of 30 kilometers. Heavy ashfall smothers towns near the caldera and spreads as far away as Rome, 225 kilometers away. The city is pelted with more than 20 centimeters of ash. Enough to cause roofs to collapse and kill thousands of people. Smaller amounts of ash fall across Eastern Europe and parts of Asia, but even small amounts of ash cause big problems.
Even a dusting of a few centimeters would create total disruption to transport systems, to water supplies, to things that we regularly rely on in our daily life. Enough to bury plants, enough to strip the branches and leaves off trees and things like that.
The enormous quantity of ash and sulfuric dioxide released by the volcano triggers a planet-wide condition, one affecting millions.
Atmospheric models are predicting that the temperature could drop several degrees centigrade, and this would affect weather for many years, 4 or 5 years perhaps after a very large eruption. And temperatures would change, areas where crops would grow may not be able to grow those crops.
Huge areas of vegetation would die. Millions could starve to death. Ultimately, the entire planet and everyone on it would be dramatically affected.
If you consider the number of volcanoes, supervolcanoes around the world that could potentially produce super eruptions, recognizing the fact that there are probably several out there that we don't know about yet, we've still got a huge amount to learn about this scale of volcanism, then there's possibly something like a 1% chance that an eruption could happen in the next 100 years, which is quite high, actually.
High enough for scientists to urge discussions of this type of disaster in the international community. Volcanologists know that there is no way to prevent an eruption. So they learn from the past and study the present in order to help mankind prepare for the future. Tsunami, the ocean's deadliest force. Giant waves with immense power. Massive, unstoppable, deadly.
A level of destruction that was, over hundreds of miles of the coastline.
We'll travel the globe investigating some of the world's most devastating tsunamis. Each bigger than the last, each packing more punch, each taking us one step closer to a mega tsunami. A wave that will not just rewrite the record books, it will erase them. No coastline on the planet is truly safe from tsunamis. They're caused by massive displacements of water, triggered by the Earth's most powerful forces, earthquakes, landslides, and volcanic eruptions.
As long as we have earthquakes on Earth and landslides, the various phenomena that create tsunamis, we're going to have tsunami waves. It's just a matter of time when the next one strikes.
Tsunamis are dramatically different from the typical waves that constantly sweep across the planet. They can travel faster than 800 kilometers per hour. They can stretch for thousands of square kilometers across the ocean's surface.
It's a good 15, 20 feet tall. Easy.
They strike with huge mass and terrifying velocity. The most common method of gauging their height is run-up, the wave's highest point of impact on land. Each tsunami profiled here has a higher run-up than the last. Over 100 major tsunamis have struck in the past 100 years, killing hundreds of thousands and destroying billions of dollars of property. But they are not the biggest tsunamis to strike the planet. Scientists have found startling evidence that even larger waves have occurred in the past, mega tsunamis.
These things have been described as culture-ending events.
Experts believe that a mega tsunami lies in our future. To understand its power, scale, and potential, we'll first investigate 5 of the most destructive tsunamis of the past 60 years. Each has its own character, each has its own story, each brings us closer to a mega disaster. Hawaii is a tropical paradise that attracts millions of tourists. But this Pacific island holds a dark secret. It's blasted by more tsunamis than almost anywhere else on the planet.
The Hawaiian Islands, sitting as they do in the middle of the Pacific Ocean, are affected by tsunamis from all regions of the Pacific.
The Ring of Fire is a volatile fracture zone surrounding the Pacific Ocean plate. 90% of the world's earthquakes occur here. Earthquakes are the most common cause of tsunamis, which is why Hawaii gets hit often and from all directions.
Destructive tsunamis struck here in 1837, 1868, 1877, 1923, 1946, 52, 57, 60, and 64.
This makes it the unofficial tsunami capital of the Pacific. 2:28 a.m., April 1st, 1946. A magnitude 8.1 earthquake rips through the Aleutian Islands off the coast of Alaska. A huge stretch of the ocean floor is uplifted, displacing the entire column of water above it. A massive pulse of energy propels a wall of water, a tsunami, towards Hawaii at nearly 800 kilometers per hour. (3,800 kilometers away in the small seaside village of Laupahoehoe, children and teachers gather to prepare for the day's classes. Marsu McShane is one of the teachers.
We were in our cottages, and the Akionas who lived in that house that's no longer there
knocked on our door and said, "Come see the tidal wave."
At first glance, it's deceptively innocent.
We looked over and the ocean sucked out, and then it came in a little bit more, like emptying a bathtub, and sucked out again. And we said, "This is a tidal wave? I don't think much of that."
What Masu doesn't know is that tsunamis are not single waves. They move forward in what's known as a tsunami train, a group of waves of many different sizes. First waves are seldom the largest, so what appears to be insignificant is actually the precursor to something much, much bigger.
And then it did it again. And this time, it went in further and sucked out more. And we thought, a twin tidal wave, how interesting and odd.
As the water recedes, an extraordinary 152 meters, Masu and her roommates pose for a photograph. Masu stands captivated while a third wave approaches.
Famous last words, I said, "I hope this will be a big one." And it kept coming. And that was the first time we ever thought to be afraid.
As the tsunami approaches shore, it behaves like a giant train wreck. The front of the wave slows while the back continues to push. The wave's energy is compressed, forcing it to stand and lift out of the sea.
This got bigger, and so we dropped the camera, ran inside. I can remember the water just crashed in the windows. The roof fell down.
The wave tosses Masu like a rag doll, at first in towards the school, but then suddenly out towards the sea.
And I knew I was going to die.
Masu spends the next 9 hours clinging to debris before finally being rescued. She is the only lucky one. All of her roommates perish. At the school, 16 children and 5 teachers are lost. But the tsunami is not finished with Hawaii. 37 kilometers south of Laupahoehoe, the sleepy trading town of Hilo Bay is also caught unawares. Here, the tsunami destroys nearly 500 homes and businesses, kills 96, and injures hundreds.
Descriptions of the 1946 tsunami were that it came across the breakwater with the greatest of ease, just overcame it, and then washed across town. Other people describe seeing boulders blasted out as the water surged across.
Walter Dudley is an oceanographer from the University of Hawaii in Hilo Bay. For more than 20 years, he's studied tsunamis. One of his most significant findings is that their destructive power is caused not just by the wave itself, but also by what's underneath them.
Well, one of the things that makes them such an interesting phenomenon to study is that they are all different. And as they travel across the oceans, they're affected by the ocean floor along their tracks. So the waves are constantly being bent or refracted. And then as they come ashore, they are further altered.
No two pieces of coastline are the same. Each has its own unique undersea topography that affects the waves differently. In Hilo, it is the natural rounded shape of the bay.
You can think of a bathtub, and as little children get in a bathtub, they can slosh the water back and forth, and they quickly find out that there's a speed at which the water will really move.
The first 2 waves to hit the bathtub-shaped Hilo Bay caused the water to slosh back and forth. When a third wave arrived, it combined with the sloshing water to produce a larger and more destructive wave.
It pretty much wiped out everything that was on the ocean side of town. In the main parts of downtown, it picked up the railway and it twisted the railway rails into pretzels.
The third wave reached a run-up height of 9 meters. It destroyed most of the foreshore of Hilo Bay. But less than 15 years after the '46 disaster, Hawaii would again be hit by a deadly tsunami. A wave bigger than the last that would defy logic and bring Hilo to its knees once more. On May 22, 1960, the largest earthquake in recorded history ruptures the Earth's crust off the coast of Chile. 1,000 kilometers of the ocean floor is violently thrust up 20 meters, spawning a monster tsunami. It's so huge and powerful that it crosses the entire Pacific Ocean, slamming into Hawaii on the way. This time, technology installed since the 1946 quake warns residents of Hilo Bay 5 hours in advance. But the warning falls on deaf ears.
In the preceding 12 years, about 3 out of 4 alarms had turned out to be small tsunamis. So instead of inspiring fear, let's get away from this potential disaster, I think it inspired curiosity, because it is a fascinating phenomenon. Let's go down and watch.
Although the civil defense were saying people evacuate, there were a lot of us, me included, that out of curiosity went down to look, to see what was going to happen.
Local real estate agent Al Inouye and many others assume that because this wave is coming from the southeast and Hilo faces the north, the bay will be spared. They are wrong. Just after midnight, the first wave strikes.
You could hear people yelling and screaming behind me that were being caught in a wave. That was an experience because, and it still stays in my mind, all this screaming and yelling, and I couldn't do anything about it. It sounded like several trains, rushing down a track. I mean, it was really a roar. And, you can hear the crashing of houses against each other. It's hard to describe. It was just a sound that you don't want to hear again. I mean, it was horrible.
Dawn breaks on a nightmare. 61 people are dead and more than 700 buildings destroyed or severely damaged. The 1960 tsunami took locals and experts by surprise. After thorough study, scientists discovered a remarkable aspect of the tsunami. As the wave reached the shallow water off the southeast coast of the island, the middle of the wave slowed, while the outside of the wave kept moving, causing the wave to wrap around the island. Then, just as in 1946, the natural shape of the bay added to the tsunami's destructive power. This time, the largest wave had a run-up height of 10.5 meters, 1.5 meters higher than in 1946. But Hawaii wasn't the only location struck by the monster tsunami. It roared thousands of kilometers across the Pacific, striking virtually every coast, including Japan, where 122 people died.
Tsunamis have an incredible amount of energy, and as they travel across the ocean, they use up very, very little of that. It's when they come ashore that all that energy is unleashed.
The 1946 and 1960 tsunamis gave scientists new insights into the complex behavior and ocean-crossing power of these giant waves. But when a local tsunami hits Japan, it strikes with larger and more powerful waves than the 46 and 60 Hawaiian tsunamis combined. And there's no time to evacuate. And later, a tsunami that combines sudden impact with awesome size, a mega disaster. The 1946 and 1960 Hawaiian tsunamis had run-up heights of 9 and 10.5 meters. Shaped and intensified by the ocean floor and coastline, they smashed the island communities with unexpected force. But there's another tsunami hotspot where a larger and more deadly wave struck without warning. Second only to Hawaii, Japan is the most tsunami-prone location in the Pacific. The Japanese have been hit so many times by these giant waves that they created the word tsunami, meaning harbor wave, to describe these terrifying events. These waves can come from as far away as Chile or as close as 80 kilometers offshore. The locally generated tsunamis pose the greatest danger. They strike within minutes of being formed and with awesome power. (10:17 p.m., July 12, 1993. A magnitude 7.8 earthquake rips the ocean floor off the coast of Hokkaido. The epicenter is only 80 kilometers from the tiny island of Okushiri and generates one of the biggest and most destructive tsunamis Japan has ever experienced. Fisherman Jiro Adachi from the village of Aonai knows about tsunamis. He survived one 10 years earlier that also hit Okushiri. When Jiro feels the earthquake, he knows a tsunami is probable. He quickly evacuates his wife and children from their seaside home, sending them to higher ground in the car while he shuts off the gas. He moves swiftly, but not swiftly enough. Just 4 minutes after the quake, the first wave hits him with overwhelming force as it surges to an incredible 15 meters.
It started to pull me back into the sea. I held on to something and thought that I must run to the mountain.
Somehow, Jiro manages to find firm ground. He flees to the safety of a nearby hill. In a few terrifying minutes, the tsunami destroys 80 houses and fishing shacks. But the danger is not over. Out of the darkness, a second wave strikes. Homes, boats, cars and trucks, spared by the first wave, are smashed to pieces. Fires erupt as gas pipes burst. Aonai is under siege. Jiro and other survivors rush to the waterfront to help the injured.
We heard people shouting for help. They were calling, "Help me, help me." I heard a lot of voices, women's voices and children's voices.
Suddenly, amidst the cries for help, Jiro hears something that chills his heart.
Suddenly I heard a familiar voice between wave breaks, so I shouted, "Achan, is that you, Achan?" And then I heard, "Daddy." I heard that from the darkness.
His young daughter is somewhere in the raging sea. As Jiro's family fled, the tsunami's first wave rolled their car and hurled them into the ocean. Jiro dives into the turbulent waters.
Normally I'm a great swimmer, but this was incredibly difficult. Sometimes I was swimming, but I couldn't move forward at all. And other times I'd suddenly be pulled backwards by the sea.
Miraculously, father and daughter make it to shore. 7 hours later, the Coast Guard finds Jiro's wife and son kilometers out to sea, clinging to debris. As dawn breaks, the tsunami's power becomes horrifically clear. Large parts of Aonai are completely flattened. Fires continue to rage, and most of the fishing fleet is lost. Across the island, 437 houses are destroyed and more than 800 severely damaged. 198 people are dead. The aftermath of the disaster confronts scientists with an intriguing mystery. The two waves that hit Aonai came from completely different directions.
The first wave of the tsunami came from the west area where the seismic center was, and it attacked only the low part in the south area of Aonai.
But the second wave came from the east, away from the tsunami's source.
The second wave came in just 10 minutes after the first, and it attacked all of this area of Aonai.
The The first wave that hit the west coast of Okushiri came directly from the source. But then, just like in Hawaii, the tsunami wrapped around the island, creating a second wave that struck Iona from the opposite direction. But the wraparound effect does not explain why the tsunami hit Okushiri with such brutal force. The reason is the extreme proximity of the event which created the tsunami. After a tsunami is generated, it radiates out like ripples on a pond. As the ripples expand wider and wider, the energy spreads out over a larger area. The closer the source of the tsunami is to the impact zone, the more concentrated the energy. Okushiri was only 80 kilometers from the source, so it received the full brunt of the tsunami. Just north of Aonai, the waves reached a staggering 31 meters. Today, the legacy of the 1993 tsunami is set in concrete. Huge walls up to 11 meters high and extending 14 kilometers along the coast stand guard against the sea. Powerful steel gates protect river mouths, and the harbor is bolstered by concrete blocks to reduce wave impact. These ramparts against the waves are stronger than normal sea walls for good reason. The forces they must withstand are utterly different. Normal waves form through the transfer of energy from the wind to the ocean surface. Tsunamis are generated by phenomenal transfers of energy. Even the largest wind waves have a maximum wavelength from crest to crest of a few hundred meters. Tsunamis can have wavelengths of hundreds of kilometers. When they hit, they keep coming and coming. In a unique experiment, scientists in Japan are measuring the impact of those forces. At this lab in Kanagawa, engineers are using the largest man-made tsunami in the world to help design stronger coastal structures. This machine can generate waves more than 3 meters high, propelling 300 cubic meters of water down a 180-meter long chute.
The best thing is to know the characteristics of the power of tsunami in each situation and build buildings according to those characteristics.
Taro Arikawa leads a team that measures the power of tsunamis under controlled conditions. This tsunami is only 2/3 of a meter high, but it strikes with 1 ton per square meter of power. To demonstrate what that kind of power can do, Arikawa puts himself in the wave's line of fire. Without the rope and harness, he'd be swept away by this miniature tsunami. Bigger tsunamis are even more powerful. This 2.4-meter wave hits with the force of 10 tons per square meter. Even after the initial impact, it continues to surge forward with a sustained pressure of 4 tons per square meter. The tsunami in Okushiri was much higher and hundreds of times more powerful. Scientists here believe their studies will translate into stronger and better engineered structures, capable of withstanding tsunami strikes.
Once we can reduce the power, the reduced destructive power of tsunami coming ashore would not cause as much damage.
The Okushiri event shows how destructive a local tsunami can be. It strikes with undiluted power and too quickly to respond. But that disaster was eclipsed by a far bigger and more deadly tsunami. A wave generated by an earthquake so powerful it moved the entire planet. A wave that takes us one step closer to a mega disaster. The tsunami that hit Okushiri, Japan, came from just 80 kilometers away and reached a run-up height of 31 meters. It killed 198 people and destroyed most of the fishing village of Aonai. but it pales in comparison to the deadliest tsunami of modern times. (7:58 a.m., December 26, 2004. Deep in the ocean off the coast of Sumatra, Indonesia, 1,200 kilometers of the Earth's crust ruptures in the second largest earthquake ever recorded. The 9.3 quake shatters buildings and destroys lives. But it is just a forerunner of an even more horrific disaster. An epic tsunami spreads across the entire Indian Ocean, striking 12 countries. As with Okushiri, Japan, the local effects are the most immediate and the most devastating. 16 minutes after the quake and 250 kilometers from its epicenter, northern Sumatra is struck by 35-meter-high waves. The capital city of Banda Aceh is decimated. More than 160,000 people are killed. Coastal engineer Jose Borrero arrived in Banda Aceh 4 days behind the tsunami.
I've seen hurricane damage, and I've seen some flood damage before, and I've seen a lot of tsunami after effects before also, but this definitely was the worst. What was amazing about it was the scale.
70% of all buildings in Banda Aceh are flattened. More than 70 kilometers of coastline show evidence of wave heights above 30 meters.
It was a level of destruction that was over hundreds of miles of the coastline, the same level of destruction. So it wasn't just isolated pockets of areas that were wiped out, but the entire coast and then the entire city of Banda Aceh.
An hour and a half after Banda Aceh is leveled, the tsunami strikes Thailand. A wall of water swamps beachside villas, hotels, and villages.
That wave is a good 15, 20 feet tall. Easy. Get in.
More than 8,000 people die. (2,000 kilometers to the west, on the island nation of Sri Lanka, 100 billion tons of water surges inland, killing 35,000 people and leaving another 500,000 homeless. In all, nearly 230,000 people die in the most devastating tsunami in recorded history. The death toll higher than for all other major tsunamis in the past 300 years combined. The power of the earthquake that triggered the tsunami was staggering. The entire planet's sea level rose by 1/10 of a millimeter. Every spot on Earth moved at least 1 centimeter. As scientists struggle to comprehend the enormity of the event, a bizarre anomaly comes to light. One that took an additional tragic toll. The morning of December 26 is quietly dawning on the peaceful shores of Galle, Sri Lanka. British tourists Camilla and Dominic Welby are sleeping in their beachside bungalow with their 11-year-old son, Hector. Suddenly, Dominic is wakened by a strange noise.
I went outside onto the veranda and I noticed that the water, which should have been at low tide, was up against the wall of the garden.
What Dominic is seeing, without realizing it, is the first sign of the tsunami. At the point of its creation, the bottom of the tsunami, called the negative wave, went east towards Thailand and Indonesia, while the top, called the positive wave, went west towards Sri Lanka. When the bottom of a wave arrives first, gravity sucks the water out, lowering the sea level. When the top of a wave arrives first, it comes like a flood. This is what the Welbys are experiencing.
I didn't know what it was. And at that moment, the floor exploded.
The tsunami rushes in, destroying the bungalow.
The force of the water was phenomenal. You know, to be exploded out of your bed, you know, to feel a piece of furniture just be thrown up into the air and to be thrown off it and to have to jump it's just very weird. And to then be sucked out and tossed around like being in a washing machine.
The couple grab their son and scramble into the bathroom.
With each wave, with the intensity of each wave, it would fill up the shower cubicle completely. We would be swirling around underwater, trying to, regain our purchase on whatever we could find.
As the waves continue to pound, the concrete walls of the bathroom begin to crumble. Hector is trapped under a large piece of concrete, struggling to keep his head above water.
The idea of your child dying before you it's nothing worse.
A third wave surges over Hector's head. He's seconds from death. But instead of drowning him, miraculously it lifts the concrete slab off his foot and releases him. The wave that's caused so much death in this one instance is life-saving. But mostly, the peculiar behavior of tsunami waves proves deadly. Surging forward and sucking back, billions of tons of swift-moving water carry a dangerous mass of deadly projectiles, broken timber, glass, metal, and vehicles. The third wave turned Gaul into one of the hardest-hit areas in the nation. As the people of Sri Lanka struggle to recover, tsunami scientists like James Goff arrive in the devastated nation.
One of the really difficult things when you go into these areas is you are going there because you have a mission to learn about the tsunami from a scientific point of view. It's very important to learn these things, and yet there is the human tragedy going on around you, and it's very difficult to isolate yourself from that human tragedy.
Amidst the horror, Goff and his colleagues discover the oddity of the third wave.
So there's Gaul quietly sitting there, recovering from being hit by two waves, and then bang.
How and why the Gaul area was hit by this third wave intrigued experts. Where did it come from? The first clue in the mystery was uncovered by looking at a global map. Sri Lanka is directly in the line of fire of the tsunami.
Sri Lanka was basically staring down the barrel of a loaded gun in a way.
The second clue came only after careful analysis of the tsunami's unique behavior.
So the tsunami wave goes all the way past Sri Lanka, heading off to the east coast of Africa. But on the way, whack, it hits into the Maldives, and a lot of the energy is reflected back from the Maldives, and the first place that hits is Gaul.
The tsunami was so powerful, its reflected energy carried a third wave 800 kilometers back across the Indian Ocean. In total, over 4,000 people died in the Gaul region. The tragedy confirmed scientists' theories about the phenomenal reflective power of tsunamis. The Indian Ocean tsunami continues to provide scientists with complex and compelling new data, most of which is still being processed.
It's really difficult to say right now what the Boxing Day tsunami taught us compared to what we didn't know before, because it's taught us so much. It taught us that we actually don't know a lot and that we have a lot more to learn.
What the Welbys learned is that life is fleeting and precious. In appreciation for their survival and in recognition of the thousands that did not, they spearheaded a fundraising effort back home in England. To date, they've raised $25,000 for the people of Gaul. Many mysteries about the Indian Ocean tsunami remain unanswered. One of the biggest questions is how the highest waves could possibly have reached a staggering run-up height of 35 meters. Far beyond what had been thought physically possible by an earthquake-triggered tsunami. But as huge as that tsunami was, it is not the biggest wave to strike in recent history. Landslides can trigger a different kind of killer wave, producing a tsunami of monstrous size. And scientists believe a mega tsunami looms in our future, a wave of such epic proportions that nothing like it has been seen since prehistoric times. The 2004 Indian Ocean tsunami unleashed a series of enormous and deadly waves that had run-ups of 35 meters. But they are dwarfed by another wave that forced scientists to become detectives. What they discovered was a new kind of tsunami, one of unimaginable size and power. In a remote bay in southwest Alaska, a native legend tells of a beast that shakes the ocean and destroys those who walk its shores. In 1958, a local fisherman came face to face with that beast. A mysterious wave more than twice the height of the Golden Gate Bridge. The story of this incredible phenomenon began 5 years earlier, with 2 American geologists on assignment in remote Lituya Bay, Alaska.
We were in the bay mapping the geology and primarily interested in the stratigraphy because of the oil potential of that part of the Gulf of Alaska.
They didn't find any oil, but they did find one of the scientific mysteries of the century. George Plafka was one of the scientists.
One of the obvious things you see when you're in that bay, if you're looking closely, is that the trees are of different ages as you go away from the shoreline.
Plafka and his colleague noticed that a band of younger trees circled the entire bay hundreds of meters above the water. The scientists knew this dramatic change in vegetation meant a large-scale disaster had struck the area. But they saw no evidence of fire or avalanches.
And so we speculated about what that could be and had all kinds of ideas about glaciers shoving forward very rapidly. The other was that there were submarine slides going on at some of the deltas along the margin of the bay, or that there was breakouts of large amounts of water up higher along the glaciers and then they flood down all of a sudden. We had everything except the right way, the right idea about how those waves could form.
The geologists left Lituya Bay without solving their mystery. 5 years later, they got their answer. In 1958, Howard Ulrich takes his 8-year-old son, Howard Jr., on a fishing trip to Lituya Bay.
So we went into our favorite anchoring spot and dropped our anchor and made supper, and finally about 9 o'clock we went to our bunks.
An hour later, the boat starts shaking violently. An 8.3 earthquake centered 21 kilometers from Lituya Bay rips across the water. Howard and his son rush up on deck just in time to see the most amazing sight of their lives.
It looked like a big explosion, like you've seen big explosions in the water on TV. That's exactly what it looked like.
What happens next defies the imagination.
As the spray started to settle down, out of the bottom of it came this huge wave. I would say that the wave was close to 1,000 feet high at that time, the actual wave.
Traveling at an estimated 112 kilometers per hour, the liquid mountain is charging straight for Howard and his son.
Just coal black and full of logs, just straight up and down. It was actually a pretty horrifying looking sight. I just thought, you know, this is the end. There's no way you're going to get out of this, you know.
In a desperate attempt to keep control of his boat, Howard turns on his engine and drives directly into the beast.
started pulling all the anchor chain out, and when it got to the end of the chain, I thought it was going to pull the bow of the boat under, but it snapped that chain just like it wasn't even there.
The giant wave lifts the tiny boat high into the air.
And I looked out over the stern of the boat, and we were looking down on the trees, and I figured that's where we were going to end up.
Unbelievably, their boat rides up and over the wave, and the Ulriches land back in the bay unharmed. 2 other vessels and their 4 occupants are not as lucky. This incredible footage was filmed the next day. Everything in the wave's path is destroyed, no trees are left standing, and most soil is ripped off down to bedrock.
The run-up height of 1,740 feet is the world record, I think, for anything that's happened in historic time. And it was, it's 500 feet higher than the Empire State Building. That's pretty big.
The earthquake felt by Howard triggered a massive rock slide, sending 30 million cubic meters of mountain hurtling into Lituya Bay. The debris slammed into the water, creating the giant wave.
It just swooped down a very steep slope and ran out into the fjord and basically forced all the water out of that little arm in front of the glacier and shot it up over the ridge that was on the other side.
One mystery remained. The amount of water displaced exceeded the amount of land that fell into the bay. It took 42 years to solve this mystery. Scientific models determine that the rapidly moving landslide created an air pocket behind the wave, preventing the water from sloshing back. The force of the air pocket combined with the size and weight of the landslide shot the water out of the bay like a missile.
It would be the same as if you took a paddle and ran it down, pushed into the water full speed at a high velocity, just push all the water right out.
The effects of the giant Lituya Bay wave remain clearly visible today. The event rewrote the history books and changed our understanding of tsunamis forever. Landslides can and do produce waves far larger and more destructive than ever thought possible. Lituya Bay's desolate location limited the damage caused by the giant tsunami. But should an even bigger landslide-generated wave strike a major city, the result will be a mega disaster. In 1958, a landslide-generated tsunami, taller than the Empire State Building, obliterated an Alaskan inlet. It was a devastating display of nature's power. But across the Pacific Ocean, on the gentle slopes of Oahu, Hawaii, scientists have uncovered evidence of a potential disaster that would dwarf the Indian Ocean and Lituya Bay tsunamis combined.
It's almost incomprehensible, the scale, the enormity of these things. It would be quite a view.
Gerald Fryer is a geophysicist from the University of Hawaii. He uses advanced computer modeling and field data to forecast tsunamis. His research has uncovered a potential wave so big that even the best laid evacuation plans may not be enough.
These things have been described as culture-ending events. The state would essentially be knocked back to the Stone Age.
This mega tsunami would combine the dizzying height of a landslide-triggered wave with a tsunami that strikes a densely populated landmass, in this case, Hawaii. On the island of Oahu, locals and tourists alike flock to the sea, soaking in the perfect climate and idyllic lifestyle of one of the most iconic coastlines on the planet. But in our scenario, everyone is oblivious to the fact that less than 480 kilometers to the east, a disaster of biblical proportions is about to strike. The mega disaster is triggered by the eruption of the world's largest volcano, Mauna Loa, on the big island of Hawaii.
In the case of Mauna Loa, and that's the 800-pound gorilla here, that's the big volcano that we have to worry about. As Mauna Loa is preparing for eruption, the southwest rift zone of Mauna Loa inflates with magma. The entire mountain swells, which means that the outer slopes get steeper. There are probably a succession of small earthquakes, and then maybe a big earthquake that shakes loose this very steep western flank of the volcano.
Almost 1,500 cubic kilometers of earth and rock plummet into the sea. On impact, the land displaces a massive amount of water. The ocean rushes back to fill the giant gap. From this cataclysmic disturbance emerges the tsunami, heading directly for Honolulu. Estimated time to impact, 30 minutes.
This is the direction that a big tsunami would come from the big island.
The wave first becomes visible as it stands and breaks on a shallow bank, 40 kilometers southeast of Honolulu.
You'd see the sea rear up in front of you. It would be huge. It would rise up above you the size of a building, the size of a 10-story building.
Surging inland at up to 70 kilometers per hour, the tsunami slams Honolulu. Because the tsunami's energy stretches down to the ocean floor, this wave is not clean water. It's filled with sand, coral, and rock. Water penetrates 16 kilometers inland before being sucked back out to sea in a lethal maelstrom of wreckage. It annihilates nearly everyone and everything in its path.
These giant landslides, as far as we can tell, they seem to occur during periods of high sea level when the climate is warm. Quite why that is, we don't know. But we are in a warm period right now with high sea level. So we should expect something like this within the next 10 or 20,000 years.
As the unofficial tsunami capital of the Pacific, Hawaii is preparing for the future. Scientists continue to develop a global network of warning systems based on real-time seismic analysis and deep-sea wave sensors. Alarms will sound as soon as 90 seconds after the initiation of even a small tsunami. Tsunamis are global-sized events with global ramifications. They combine the almost unlimited power of the Earth with the gargantuan might of the sea. They are a humbling reminder of the transience of man and the awesome strength of nature. While scientists learn more about tsunamis, engineers build stronger coastal barriers, and experts implement improved warning systems, individual vigilance remains essential.
And you see the water withdrawing, strangely, curiosity shouldn't compel you to go down and see what's going to happen next. The alarm bell should be going off.
It's something that we need to have embedded in our culture, in our knowledge base, and in our education so that we know what to do when the next tsunami happens. Not if, it's when. It's something we need to learn to live with.
As long as we continue to have the phenomena that create these giant waves, we will continue to have tsunamis. It's just a matter of time before the next one strikes. tornadoes are unpredictable,
Back the f up!
volatile,
The whole country looked like it was in a nuclear blast of some kind.
and lethal.
I kept talking to myself, thinking, well, this is it.
They leave behind obliterated towns
There were no houses left. They were all gone.
and bewildered scientists.
It's not an exact science.
Each tornado is unique, most dangerous, a few deadly. From the tremendous to the terrifying to the tragic, this is a countdown to a mega tornado, one that experts believe will devastate a major American city. The most ominous tornado warning comes when an apocalyptic-like darkness fills the sky. These clouds are precursors to a powerful storm, a supercell. Most tornadoes form when a violently rotating column of air stretches down from that supercell to touch the Earth. In general, the faster the wind speeds, the more dangerous the tornado. Surprisingly, relatively little is known about these giant killers. Scientists are literally chasing the mysteries of tornadoes across the Great Plains of the United States, better known as Tornado Alley. More than 400 tornadoes threaten to wreak a path of destruction here every year, far more than any other place in the world. The main reason? Ideal atmospheric conditions.
The mountains to the west, the Gulf of Mexico to the south, and the fact that there are no physical barriers between here and the North Pole means that we are frequently changing air masses from warm to cold and back again.
Tornadoes are measured using the F scale, F for Dr. Theodore Fujita, who classified tornado strength by estimating wind speed based on devastation. The smallest twisters are F0s. They can reach 116 kilometers per hour, about the equivalent of a small hurricane. At the other end of the scale are F5s, whose winds reach speeds of up to 512 kilometers per hour.
Back up! Back up! Keep going, keep going, keep going!
The tornadoes profiled here rise up the Fujita scale from an F2 that rips the roof off a house
Did you see that?
to an F5 that lays waste to an entire neighborhood. It's all leading up to a mega tornado, one that some scientists fear will ravage a primary city. "111 kilometers southwest of Wichita lies the small town of Attica, Kansas. Just over 600 people live here. It's a town you could easily miss. On May 12, 2004, a tornado didn't. On that day, the blue skies over Harper County fill with storm clouds. Shortly after 6 p.m., Dan Smithheisler heads into Attica.
I did some work for the banker in there. And I told his wife, I said, you know, it's going to storm today.
Several thunderstorms form over southern Kansas. One look at these storms tells 30-year veteran meteorologist Chuck Doswell they might be a breeding ground for tornadoes.
One of the important ingredients that produces a tornado that we're pretty sure is the wind at low levels has to change direction and speed rapidly with height. We call that vertical wind shear.
The vertical wind shear typically spins the air into an invisible cylinder. As the wind speed increases and rises, the tornado intensifies and the core pressure drops. Condensation from the dropping pressure builds down the funnel, creating a visible tornado. That's exactly what's happening in the southern Kansas sky. Harper County Emergency Management Director Mike Lorig gets the first tornado warning at 6:45.
And when they start giving us those warnings, we listen and we say, hey,
We need to start warning our public from there. We do not know if this is going to be an F0 or it's going to turn into the monster.
In Kansas, meteorologists carefully follow the thunderstorm as it tracks towards Attica.
About 7:25 in the evening, a F2 tornado had made it to ground right up here just on this hill. The path of it was right across here.
As Lorig watches in astonishment, the tornado tears the roof off a home directly in front of him.
Oh my God! Oh my God! The whole house came apart!
This act of violence is just one of many. The angry skies over Kansas are far from finished.
We thought, okay, hopefully things are over. We got emergency crews set up for that. And then the storm just suddenly, it took a life on its own.
Storm chasers tracking the Kansas supercell relay information to meteorologists using mobile Doppler radar. They report the tornado's wind speed, location, and one other startling fact: the storm is producing multiple tornadoes. Look at that. Storm chaser Yvette Richardson seen a supercell create more than one tornado before.
It can be a very dangerous situation because often people will be looking at the main tornado and feeling that as long as they're far enough away or they've taken cover that they should be completely safe.
Her team and others report seeing 16 tornadoes. They vary significantly in size and power. The biggest is an F4, roughly 160 kilometers per hour faster and with corresponding wind force about 3 times larger than an F2. The F4 heads straight for Dan and Donna Smith-Heisler's home.
I was listening to the radio and the TV, and they had it exactly pinpointed. They knew exactly where it was at.
Knowing a tornado's path gives potential victims an average of 12 minutes warning, enough time to save their lives. The Smith-Heislers get the warning, but Dan ignores it. Mesmerized by the golf ball-sized hail that often precedes a tornado, he refuses to join his wife down in the basement.
That scared me, and so I started screaming at him to get down, and the dog would not come down. He said, well, Sugar won't come. And she was going in the door, out the door, in the door. Dogs are smart. They know. So when I screamed at Sugar, then she came down. He came down.
We started hearing this popping noise. Well, we had a rack of canned goods over there.
Before.
And those cans were popping from the pressure change.
I can't even.
It sounded like popcorn going off over there.
The tornado batters Dan and Donna's home with winds estimated at more than 322 kilometers per hour.
And that's when I got hit on the head with cement or something, you know. I can still hear myself groan. All of a sudden, you're just going to, like, go with it. And that's where I was when he said, we're not going to make it. And that woke me up. And I said, oh, yes, we are too, you know. And you pray really hard.
The savage winds rip unrelentingly over the Smith-Heislers' home. When they finally stop, the couple emerge from their basement and into a war zone.
And I thought, where's the car? And then my next thought was, where's the garage?
The twister destroyed the couple's 2-story home, 5 barns, dismantled 5 cars, and killed their dog, Sugar.
The terror down there was the worst part. The terror.
The Smith-Heislers are lucky to be alive. With estimated wind speeds near 400 kilometers per hour, the F4 tornado easily destroyed their home. But even the earlier F2, with winds estimated at 240 kilometers per hour, was capable of ripping the roof off this home. Complex physics transform air into a lethal force, a concept scientists are laboring to understand.
What we are trying to do is simulate the tornado as best as we can. So we're actually comparing the wind which we generate here with the measurements made in the field. And the match is pretty good.
Sarka's tornado simulator is the first of its kind in the world. It uses dry ice to create a visual display of the wind inside a vortex. His machine can produce tornadoes up to 1.2 meters in diameter and 2.4 meters tall. It can reach peak wind speeds of 86 kilometers per hour. When combined with scale models, he's able to replicate damage much larger and faster tornadoes inflict on homes and other structures.
Normally, a portion of the roof fails and create a hole in the building, which then the flow starts getting inside, which then creates more load on the walls, and eventually those walls start failing.
Sarka's experiments conclude that the destructive force of circulating wind in an F3 or stronger tornado is at least 3 times more powerful than straight-line winds. Since few structures in Tornado Alley are designed to withstand even an F1's winds, this is stark proof that even the weakest tornado is capable of causing damage. The residents of Attica were thankful to have survived the fury of the 16 tornadoes that struck southern Kansas. But when a single F4 twister strikes a small Texas town, its bizarre behavior and surprising power threatens to destroy the entire city. And later, a mega-tornado strikes a major American city, something experts say will happen. In 2004, a single Kansas storm produced a swarm of tornadoes that ravaged homes, destroyed property, and terrorized hundreds. But the power and damage of that outbreak was far surpassed by the stunning force and unpredictable behavior of a single Texas twister. Pampa, Texas has had its share of luck. The town has prospered since oil was discovered here in 1921. Today, 17,000 residents work the hard soil, farming, ranching, and refining oil. But the town's location in the Texas Panhandle is also its biggest flaw. This is tornado country. On the afternoon of June 8, 1995, Pampa's luck ran out. Randy Stubblefield is a lifelong resident of Pampa. In his 2 years as sheriff, he's seen his share of violence, but nothing compares to what he's about to confront.
About 4 o'clock in the afternoon, we received a call that there was a large tornado was building on the south side of the Amarillo Highway, just about 1.5 miles from where we're standing now.
Stubblefield grabs his camcorder and rushes towards the twister.
I watched it building on the farmland on the north side of the railroad tracks, and it just started building, getting bigger and bigger.
Meteorologist Chuck Doswell is also chasing and filming the Pampa tornado.
The evolution of the Pampa tornado with respect to the parent thunderstorm was very unusual in my experience. I've never seen anything quite like it.
What Doswell sees is remarkable. The tornado is almost standing still.
Impossible to tell what's going on in there.
Then, suddenly, the tornado makes a sharp right turn. This odd behavior stuns Doswell.
Tornadoes move in a particular direction because they're tied to the storm that's producing them. And the storm that's producing them moves in a particular direction because it's embedded in a wind field which is pushing it in that direction.
But the Pampa tornado isn't moving in the same direction as the storm. After a series of sharp turns, the twister loops almost 270 degrees around Doswell. These erratic and unpredictable movements make this a very dangerous tornado.
Let's go. And I am completely mystified as to what was going on with that storm.
Then it started traveling north.
Get everybody inside, because this is one big son.
And hit a industrial complex.
Belinda Waldrop works in that complex with her father. She isn't listening to the news.
I learned that there was a tornado out outside the building when my dad came to the door of the office I was in and said, "Belinda, there's a tornado on the ground west of us." I'm curious. I said, "Can we look at it?" And he said, "Oh, no, we don't need to look at it. We need to get under some cover."
Belinda and her father dive for shelter as the twister slams towards them.
You could hear the tornado approaching. It was like a gyrating woof, woof, just a churning that just got gradually more intense and louder. The lights began to flicker as the pressure was building, and then the lights went out.
Whenever you first started seeing the real debris, the metal, the rooftops and all that, that's when it hit the first series of steel buildings in the industrial complex.
And then an explosion. The vacuum just took me up off the floor and slammed me into numerous things and was pulling me backward like a rag doll.
You're going to see some vehicles going into the air, transport trailers and truck combinations. Now these units weigh probably 22,000 pounds empty. These were sucked up and in the tornado and were going around and around.
Stubblefield and Doswell are among the few to ever film a tornado snatching up 3-ton trucks. This is a massively powerful twister, one that has Belinda Waldrop trapped in its ferocious grip.
When I was in it, everything's dark, and I just tried to keep my eyes closed to protect my eyes. I kept talking to myself, thinking, well, this is it.
And at that time, I just had a feeling of helplessness because there's nothing you can do. I mean, there's no way you can stop it, or make it go another direction or anything like that. And it was just a sick feeling.
They had dropped me out here into the parking lot and just dropped me on my back, and I could see the cloud and the tornado. It looked like a white ghost just going up and taking off.
Belinda's encounter with the tornado is over, but Randy's is just beginning.
But when I realized that it was going to go into the city of Pampa,
Stubblefield jumps back into his car and races down the road, directly into the path of the tornado.
One of my deputies gets on the air and says, "Watch out, you're too close."
Be careful, you're almost there.
You know you're too close when debris starts coming in the car with you. I had my windows down and the trash from the circulation was coming into the car with me.
It's going into the city at this time.
It was headed right straight for the sheriff's office in the downtown section. Well, I had, at that time, about 65 prisoners in jail. And, we had a big, strong building, but this is a big, strong tornado.
The twister strikes Pampa, destroying or damaging 200 homes and 50 businesses. Most buildings in the industrial park are ripped off their foundations. Belinda is badly injured and in shock.
Of course, I was just stunned and numb. I really couldn't feel anything. I felt like my legs were probably broken. I couldn't get my bearings because there was no building. There were no landmarks that I recognized at all, and I was just taken back.
Fearing the worst, Belinda desperately searches for her father.
He was draped over a motor. He looked dead, honestly. He was limp, and he wasn't moving. I managed to scoot over close to him and started rubbing him. He woke up and turned his head, and there was blood, and you could just see this white eyeball. You could just terrified look, and I'll always remember that, just stark. And he immediately said, help me up. And I can't help you up, I can't get up either.
Emergency workers rush Belinda and her dad to the hospital. Both are in serious condition. 5 other residents also suffer injuries. Miraculously, there are no deaths. As the wounded begin their recuperation, experts study Stubblefield and Doswell's remarkable footage.
To tumble a 2 or 3 ton pickup truck along the ground and then hoist it into the air, this takes incredible wind speeds, probably in excess of 150 miles per hour.
Dave Llewellyn researches the strange and complex forces at work inside tornadoes.
In a tornado, the wind is not just swirling around. It's actually spiraling strongly inwards.
Llewellyn believes that once an object like a vehicle is airborne, it can be slammed to the ground by powerful center downdraft winds, then hurled back skywards by updraft winds. This brutal cycle renders the debris unrecognizable before it's finally spat out as a high-speed missile.
Amazing. That was 4,600 pounds thrown into the crane.
Scott Schiff and his team at Clemson University are studying the damage a tornado-hurled car can do.
We're really testing this roof slab here, and this was designed to be a shelter. It's about 10 inches thick of solid concrete with a double mat of steel reinforcement, so it's heavily reinforced. It's really designed to be able to take large debris impacts.
3, 2, 1, drop!
After multiple impacts, the slab begins to crumble.
So after that last impact, we now have a permanent deformation in the slab. That rebar that's down under that bottom mat there started to yield under the load, and we started to see some more concrete spalling down below there.
To counter multiple impacts, Schiff is designing a steel mesh net to catch loose debris. If that works, it will be a huge step forward in tornado protection.
We have this terrific F5 tornado. What we're looking for is that we are safe during the event and right after the event.
Despite the Pampa tornado's unpredictable movements and incredible power, no lives were taken. 608 kilometers away, another Texas town isn't so fortunate when a massive F5 twister turns tiny bits of dirt and wood into lethal weapons. And later, a mega tornado, one that scientists believe could destroy a major American city. The powerful F4 Pampa tornado tossed trucks, destroyed buildings, and threatened the lives of hundreds. But just one notch up the Fujita scale, an F5 twister turns into a killer. Its weapons, specks of dirt and splinters of wood. Gerald, Texas was founded in 1909. Located 64 kilometers north of Austin, the town never fully recovered from the decline of the cotton industry in the 1920s and 30s. In 1997, a tornado threatened to wipe Gerald off the map. From the beginning, the Gerald tornado smacks of something strange. On May 27th, a supercell forms over central Texas.
The Gerald tornado is memorable for a couple of things. One was it formed in conditions that at the time we thought were very unusual.
The massive supercell lacks strong vertical wind shear, an essential ingredient in typical tornado formation. Meteorologist Bill Gallus teaches tornado forecasting utilizing a virtual reality tornado simulator.
To get a tornado in nature, you need to have really two things. You need a very strong updraft or updraft and downdraft to help stretch the air in the vertical. And you also need to have some source of spin present.
Strong wind shear usually provides a tornado with its source of spin. Before Gerald, the conventional wisdom was that without strong wind shear, you don't get violent tornadoes. But the unusual atmospheric conditions over central Texas are about to prove the conventional wisdom wrong. Dead wrong. Here, the warm, moist air rises so forcefully it generates a super strong updraft, creating a very powerful and dangerous tornado. As the skies blacken and the winds rage, LaDonna Peterson and her 8-year-old son leave their mobile home for the safety of her mother-in-law's brick house.
I went outside and started watching the clouds outside because they were getting real thick, real dark, real heavy. And all of a sudden, I could hear in the distance, because the wind had picked up, the alarm going off in town.
Ken Adams doesn't hear the town alarm. He's asleep.
and the dog woke me up. And I could tell that dog was really scared. I knew something was wrong, but I don't hear well, but I could feel it. It was like a thunder that you couldn't hear, you know, but you could feel it.
LaDonna's sister-in-law and young daughter join her in their mother-in-law's home. News reports place a tornado 3 kilometers away.
My sister-in-law and I went to a window, and we could actually see the tornado in the distance, but it was like it was just sitting there, just turning, not moving at all.
In fact, the tornado isn't standing still. Its forward movement is clocked at a slow pace of 16 kilometers per hour. But its internal wind speeds are reaching more than 420 kilometers per hour. Now a killer F5, it descends on the women's refuge.
Then all of a sudden we felt a gust of wind hit the house. We could actually see the asphalt being pulled up off of the street, up the road from us. We were sitting there and I said, God, please don't take my family. Then we felt a big gust of wind hit the house and the bathroom door flew open. And at that point, we just started feeling like mud and stuff start coming in, hay.
Minutes later, when Ken Adams walks outside to see why his dog is barking, he comes face to face with a nightmare.
It was so big at the base, probably a half a mile or 3/4 of a mile, that I didn't realize it was a tornado. And by the time that I did realize that it was too late to go anywhere, I ran to the house, opened the back door, and as I did, the door flew out of my hands and the roof of the house came off. I would sort of be picked up. The house would fall on me again.
Suddenly, the tornado is gone.
The whole country looked like it was in a nuclear blast of some type. When I first looked up, I thought I was dead. I mean, I really did.
Ken is wrenched back to reality when he's forced to take in the horror that surrounds him. More than 300 head of cattle were killed or injured by the tornado. Many that survived had to be shot because of the extent of their injuries.
Oh, it was terrible. There's about 300 acres over there, and most of it, you couldn't walk very far without smelling that old dead smell.
LaDonna's family emerges from the rubble of their home and into a wasteland. Nearly every home in their subdivision is obliterated. Many of their neighbors are nowhere to be seen. Others are badly injured.
Mrs. LaFrance was pinned under a tree, and her daughter was laying in the mud and had some really severe injuries to her legs and her arms. It was raining, and she was saying it was hurting her, hitting the open wounds, so the only thing I could find was a dirty blanket laying on the ground to cover her up with, just to keep the rain from hitting the wounds so bad. Later, we found out that Mr. LaFrance had been killed in the tornado, and the daughter had been crying through the whole thing, wanting to know where her dad was.
27 people died that day. Half were children. Entire families killed. As scientists studied the Gerald tornado, several intriguing facts came to light.
The thing that the tornado itself was interesting for was that it was moving very, very slowly, and it was large, and it collected a lot of debris to where the high wind speeds associated with the tornado were there for minutes in locations rather than just for a few seconds.
The tornado traveled approximately 16 kilometers per hour, significantly slower than the average 48 kilometer per hour twister. Another oddity was that most houses in the tornado's path were completely obliterated. After much study, experts found an answer. Physicist Dave Llewellyn's computer models illustrate their findings.
You can actually have thousands of tons of dirt in that debris cloud at any given time. And that dirt can change the internal structure of the tornado.
As the Gerald tornado passed over the open Texas plain, it picked up massive amounts of dirt, slowing down the funnel's forward movement while increasing its destructive power.
I think down low, that Gerald tornado probably acted like a giant sandblaster.
Llewellyn and others believe that instead of blowing apart homes with strong winds like some tornadoes, The Gerald twister destroyed structures via the massive force of wind-blown debris. The Gerald tornado was as ironic as it was tragic. Experts advise never to try and outrun a twister, but some who died in Gerald could have escaped the slow-moving storm in cars. Experts advise potential victims without storm shelters to hide in interior rooms like closets or bathrooms. But some in Gerald did exactly that and died anyway when their entire home was swept away. Still, because no two twisters are ever the same, experts advise that the best option is an underground shelter or safe room built to specific codes. The Gerald tornado changed the way experts watch for twisters. They now view storm systems with low vertical wind shear as possible violent tornado producers. But no amount of vigilance or insight could stop the deadliest tornado in US history from killing hundreds. And later, a mega tornado unseen in modern times threatens millions. The Gerald twister killed 27 people while changing the way experts keep vigil for potential tornado-producing storms. But there was no way to prepare for the deadliest tornado in US history, a brutal F5 that tore through 3 states, killing hundreds. On March 18, 1925, a single tornado slaughtered 695 people in Missouri, Illinois, and Indiana. The behemoth F5 blasted a 322-kilometer path of unstoppable annihilation that lasted for hours. Survivor accounts are chilling.
The air was filled with 10,000 things, boards, poles, whole sides of little framed houses. In some cases, the houses themselves were picked up and smashed to the earth, and living beings too. A baby was blown from its mother's arms. Children all around me were cut and bleeding. They cried and screamed. It was something awful.
The destruction was of mythic proportions, primarily because the killer struck an extremely vulnerable population.
People had very few ideas about how to deal with tornadoes. The country was largely rural instead of mostly metropolitan, and they had essentially no way to communicate with each other.
The town of Murfreesboro, where more than 100 people were killed, actually was hit more than 2 hours after the first fatalities from the tornado. And people wondered why hadn't any word gotten downstream, down the telephone lines or telegraph lines, that something was coming.
In 1925, several million people lived in small rural towns throughout Tornado Alley. Today, tens of millions call it home. Modern communication means better warnings, but evacuating a major city before an F5 strikes is still impossible. On May 3, 1999, the people of Oklahoma City faced the worst F5 in modern history.
The May 3, 1999 tornado that went through Moore in southern Oklahoma City was one of the most damaging in the history of the United States, no matter how we look at the data.
Late in the afternoon of May 3, 1999, weather forecasters in Oklahoma carefully track multiple supercell storms and then the tornado reports that begin flooding in. At home with her 8-year-old son, Dana Grimm watches the local news.
We had been watching the coverage for hours. He said it just kept building momentum, getting bigger and bigger, and if you were above ground, you weren't going to make it.
The storm system is intense, complicated, and growing. Weather trackers watch in awe and shock as multiple storms produce multiple tornadoes.
Large tornado, very large tornado.
It seemed like just about every thunderstorm cloud that formed eventually produced a tornado at some point.
And there were times when you had the main tornado happening, and then we had what we call satellite tornadoes that would rotate around it. And they're completely separate tornadoes within the same storm system.
At about 6:25 p.m., a large tornado touches down just outside Amber, Oklahoma. Doppler radar records its wind speed at 512 kilometers per hour, the fastest twister ever documented. This is a monster, and it's hurtling towards Dana Grimm's home.
And they had said that it was a mile wide and just ferocious, and it was just destroying everything in its path.
With a giant wall of howling wind just 1.6 kilometers away, Dana and her son hide in a closet.
I remember my son, he was screaming and crying. He said, are we going to be okay? I said, we're going to be fine. He said, what do we do? And I said, we pray.
Dana's fear turns to panic when she hears the tornado strike.
There was kind of a high-pitched squeal to it. And then, of course, the sound of everything, the windows just blowing out. The house was shaking. We could hear the beams in the roof breaking. The walls just lifted up, and we could feel really cold air rushing underneath. And within seconds of that, the house just blew up. And I couldn't breathe. I had sucked in so much dirt that I couldn't even breathe anymore. I thought, this is it. And I remember just praying that, God, if this is it, I'm ready.
On the brink of death, the fierce tornado spares Dana's life by lifting her out of the suffocating dirt. When it slams her back to the ground, she's paralyzed with fear.
And I realized then that I didn't have my son. So I started screaming for him, and he came running over, and it was just a miracle of God because we were both barefoot. He came running over to me, did not have one puncture wound on his feet.
The F-5 continues towards the center of Oklahoma City, crossing major highways filled with rush hour traffic. As the tornado hurtles towards them, some people panic. They abandon their cars in a desperate attempt to find shelter. For a few, that decision has fatal consequences. 3 people seeking refuge under freeway overpasses are killed by debris and the sheer force of the wind. Stranded cars block escape routes for many others.
Shields Boulevard in Oklahoma City essentially became a huge parking lot, and it blocked people from being able to escape the tornado.
By the time the F-5 dissipates, 40 people are dead and nearly 700 injured.
My wife worked in the hospital in Norman that night, and she worked in the emergency room, and they were swamped, of course. She saw some really horrific injuries. People came in covered with splinters of wood, looked like pincushions from so much wood. Awful things.
Many survivors suffer multiple painful wounds from being impaled by debris. Cheryl Brown studied the injuries and deaths in Oklahoma.
There were also injuries that were related to debris being embedded inside the body, all the way from small splinters to very large objects such as 2x4s.
Many survivors suffered debris-related injuries because the tornado destroyed so many homes, spewing countless shards of wood and other material into the air. The Oklahoma twister leveled nearly 3,000 houses and structures.
3, 2, 1, fire!
73 miles an hour.
Schiff and his team at Clemson University fire 2x4s at more than 160 kilometers per hour into a variety of structures to represent the damage done during a tornado.
I think that the public understands that tornadoes are very dangerous. What they don't understand is that in typical construction, they have very little protection against those types of events.
When debris strikes a home, it does far more damage than simply making a hole in a wall or window.
Fire!
It gives the tornado a point of entry. Once inside, inflowing air can rip apart walls and tear off the roof. The home then becomes part of the tornado's arsenal, further fueling the funnel with debris and making it even more destructive.
This type of construction is very typical for a residential, brick veneer in front of a wood frame wall. The missile's gone all the way through the wall cavity. Most people that have this type of house would be vulnerable to an F5 tornado.
Fire!
Schiff's experiments determined that for a home to withstand the deadly onslaught of debris, the brick veneer must have an 8-centimeter thick backing of concrete.
So this wall here would be suitable for a shelter to resist tornadoes.
Most homes in Oklahoma City were brick veneer with wood frames. This common construction, coupled with the sheer number of homes in the tornado's path, increased the debris field exponentially. Dana Grimm survived with a broken back, her son with a puncture wound to his chest.
I truly believe that the reason that I was thrown twice, if I had not been picked back up and thrown again, I would have suffocated because I could not breathe in anymore.
10 supercell storms spawned 70 tornadoes that spring day, including the F5 that cut a 24-kilometer path over interstate highways and devastated several suburbs of Oklahoma City.
It was sad. I think there were 14 in our own housing addition that died. And it's a miracle of God that we didn't.
The Oklahoma tornado caused more than $1 billion in damage, the costliest tornado in U.S. history.
Complete and total devastation. The homes that you see over here now were completely gone. It was a rubble pile. If you had been in the open, it would not have been a very pleasant place to be.
Things would have been much worse if the tornado had veered just 16 kilometers to the west, striking the heart of downtown Oklahoma City. Even so, the Moore, Oklahoma tornado and its companion twisters rank as the most deadly and destructive outbreak in modern history. They would be far surpassed by an F5 striking a major American city. That would be a mega disaster, one experts warn could happen. Every year, major U.S. cities in Tornado Alley play a game of Russian roulette with massive twisters that wreak havoc there. In 1999, Oklahoma City lost the game when a giant tornado killed 40 people, injured nearly 700, and racked up costs of more than $1 billion. Only sheer luck kept the tornado from striking downtown. Researcher Scott Ray knows the next major city to be struck by an F5 may not be so fortunate.
Dallas is overdue for a large violent class tornado.
Dallas, Texas is a boomtown sprawled along the southern boundary of Tornado Alley. It's one of the largest and fastest growing metro areas in the U.S. with more than 5 million residents and 600 corporate headquarters. Dallas is 10 times larger than Oklahoma City.
I was shocked a bit when I saw some of the aerial footage of Oklahoma City. The amount of damage that had occurred in that was pretty amazing.
Ray assists local governments with planning for hazards, especially threats from tornadoes. To help Dallas prepare for a possible mega disaster, he has modeled over 60 different scenarios of how the Dallas region would be affected by a violent tornado.
For reasons of credibility, it was very important that we look at an event that actually had occurred somewhere else. So we took the event in Oklahoma City basically because the data was very good for that particular event, and we could transpose it by just moving those same geographical characteristics of the tornado on top of the geography of Dallas-Fort Worth. So we got to see it kind of from our own perspective.
Ray and his team painstakingly overlaid the exact path taken by the Oklahoma tornadoes over the Dallas-Fort Worth area. A mega disaster unfolds when Oklahoma's F5 tornado rampages through downtown Dallas.
It would easily be the worst damaging tornado event that we have had to date in the U.S.
Ray's nightmare scenario begins as a supercell storm forms over north-central Texas. A 160-kilometer-per-hour tornado, an F3, touches down in a dusty field 10 miles southwest of Dallas. Its first target is the suburb of Cockrell Hill. While packing winds in excess of 320 kilometers per hour, cars are tossed aside, buildings are decimated. The tornado continues northeast, unrelenting in its assault on thousands of homes. The twister's internal wind speeds rise past 400 kilometers per hour, turning it into an F5. Fueled by tons of debris, the giant tornado slows as it descends on the busy freeway.
A clogged highway holds a heck of a lot more people than one that is moving comfortably. And the other problem that you have is, where do you go?
Panic ensues as many abandon their cars, creating a traffic jam that traps thousands. The 443 km/h winds effortlessly swat cars off the highway. Anyone hiding under an overpass is vulnerable to flying debris and violent winds. Cars snatched up by the powerful updraft winds are spun around inside a giant vortex, then shot out, creating a dangerous hazard for anyone in their path. Next, the deadly twister approaches downtown Dallas. Dozens of skyscrapers and tens of thousands of people crowd the city. Giant glass windows shatter, marble and bricks are ripped off buildings. A deadly shower of glass and other debris rains down onto the crowd below.
Most of the skyscrapers in the Dallas-Fort Worth area are predominantly covered with glass on the outside, and that's not very durable. But the amount of damage from getting wind and broken glass spread out through a downtown area is going to be pretty dramatic.
A packed commuter train snakes through the city. It swept off the tracks and slammed into a skyscraper, killing hundreds in the train and office buildings.
There's little doubt that debris would be probably the largest generator of damage in the Metroplex, and it's basically because there's so much of it that can be generated, and you name it, it could be wood, bricks, gravel, just about anything you can imagine can become a projectile, and with almost unlimited supply.
The tornado continues north, leaving the wreckage of downtown Dallas behind. Tornadic winds more than 500 kilometers per hour now descend on the suburban landscape of Lakewood. The 92,000 people living here have had up to 20 minutes to seek underground shelter, a seemingly reasonable chance for survival. But like the Gerald, Texas twister, those hiding in closets or bathrooms can only pray. Finally, the worst tornado in history slowly drifts skyward and dissipates. The war zone behind it is 61 kilometers long. Dallas is devastated.
I don't think there's any way to really sugarcoat an event. It's going to be difficult to deal with regardless. So there's going to be a lot of damage. There are going to be a lot of people that need help.
Total damages approach $5 billion. Tens of thousands are homeless and scores injured. The death toll is unknown.
Fatalities are difficult to really quantize because they involve people making decisions. And there are good decisions that can be made, bad decisions. We don't know what decision they're going to make.
The best decision city planners can make is to prepare with multiple underground shelters, rehearsed evacuation plans, and a vigilant public. But even that won't likely be enough.
I think it would pretty much be impossible financially to build a city that could really survive violent class tornadoes or, any scenario like that.
With increasing populations in major metropolitan cities throughout Tornado Alley, science is in a life or death race against time to understand one of Mother Nature's biggest secrets.
In an ideal world, we'd have radar or other instrument measurements on every tornado that occurs. In the practical world that we live in, that's just not going to happen.
Okay, this storm in the next hour is going to produce this type of tornado. We're just not there yet, and it's hard to say when we'll be there. We've certainly got a ways to go.
Given the limited ability to predict tornadoes, there is a very real cause for concern.
Most people think about disasters as very random events that can happen to them. And I think that holds true with tornadoes as well.
If you wait long enough, something resembling the worst case scenario is going to happen eventually.
Until science learns more about these brutal forces of nature, the only thing that can be done is to prepare before a mega disaster strikes. When the earth quakes, all hell breaks loose.
Oh my God, we're having an earthquake. Wait a minute. Hold on.
They strike with lightning speed, a huge bolt of destruction. These forces baffle experts, who are on a desperate mission to predict when and where the next big one will hit.
With each earthquake, you have things that you didn't predict before.
We'll circle the globe, examining significant earthquakes of our time, each more powerful than the last, each with its own compelling mysteries, each propelling us towards a projected mega disaster, a monster quake that could rock our world. Earthquakes are one of the most destructive and unpredictable forces on the planet. Without warning, solid ground cracks, shifts, and buckles, threatening anything in its path. It's estimated that several million earthquakes shake the planet every year. Most are barely detectable tremors, but at least once a year, somewhere on the globe, a major event strikes. Most earthquakes are created by movements of titanic slabs of the Earth's crust, called tectonic plates. Enormous pressure builds as the plates strain against each other. When plates slide past each other, a strike-slip earthquake forms. When plates collide head-on and one slides under the other, a thrust earthquake occurs. In both cases, the Earth's crust tears and snaps, releasing a giant burst of seismic force. The amount of energy released by an earthquake is known as its magnitude. The higher the magnitude, the more energy released. An earthquake of magnitude 8 or higher releases as much energy as 1 billion tons of TNT, or 67,000 Hiroshima bombs. Earthquakes' destructive energy has cost almost 8 million lives in the last 1,000 years. The fatality rate is rising as populations in high-risk areas increase dramatically.
And it's kind of an inevitable shift as people cluster more and more. The largest cities continue to grow larger and larger.
Today, there are 17 cities jammed with more than 10 million people. 140 other metropolitan areas have populations topping 2 million. More than half of these are within striking distance of a major fault line, placing hundreds of millions directly in the line of fire.
A lot of times, we are our own worst enemies in terms of where we build and how we build these cities.
It's only a matter of time before another city is hit by a devastating earthquake. To prepare for the inevitable future, it's essential to learn from the past. October 17, 1989, San Francisco, California. For 15 horrific seconds, the city by the bay is rocked by a magnitude 6.9 earthquake. The epicenter is near a mountain in Santa Clara County called Loma Prieta.
Everybody's door and help them get out.
Suburbs close to the mountain suffer serious damage. The ground splits open in huge gashes, hundreds of homes are thrown off their foundations, and small communities are ripped apart.
62 people were dead.
But bizarrely, the greatest devastation and loss of life is 97 kilometers to the north in Oakland and San Francisco. The quake brings down a section of Oakland's Cypress Expressway, turning a busy freeway into a graveyard. Oakland firefighter Lorenzo Frediani is one of the first to respond.
It was a horrible scene. It was such a large-scale disaster. Seeing huge pieces of the freeway on top of cars, fires beginning to erupt, everyone just yelling and screaming for help.
Frediani and other rescuers race to find survivors. They fear the worst, that thousands are dead under the shattered remains of the expressway.
This was at 5 o'clock approximately. This is its peak time. There should be bumper-to-bumper traffic. So when I saw the Cypress unfold in front of me, all I could think about was how many thousands of people would be dead.
But amidst the horror, there is a life-saving stroke of luck. The earthquake hit as the two local baseball teams, the San Francisco Giants and the Oakland Athletics, faced off in the World Series. Millions are watching the game, and traffic is much lighter than usual.
The fact that we had the ball game between the two Bay Area teams easily saved thousands of lives.
As rescuers desperately try to free those trapped on the Cypress Expressway, another disaster unfolds across the bay. Nearly 200 buildings in the Marina District are severely damaged or completely destroyed. Fires started by broken gas mains add to the damage and panic. Stunned residents flee into the streets, but even as the marina suffers catastrophic damage, neighborhoods surrounding it escape almost unscathed. Seismologists like Jack Boatwright struggle to understand the quake's selective destruction.
The ground motion and damage in the marina was a surprise not just to the lay people, it was also a surprise to seismologists.
The earthquake seemed to defy logic. It targeted two specific areas, 97 kilometers from the epicenter, leaving most of the Bay Area untouched. Boatwright and his colleagues set out to solve this mystery by going back to basics. When a fault ruptures, spherical waves of energy are released, traveling through the ground until they reach the surface. Like any other kind of wave, they can bend, reflect, or join together to make bigger waves. Oakland and the Marina District were unlucky enough to be hit by a seismic double team, two sets of waves that joined together. One set traveled directly from the earthquake center to the surface. Another traveled deep into the earth, then bounced off the boundary between the solid crust and the molten layer beneath it. The reflected waves reached the surface 97 kilometers away from their source, directly under Oakland and the Marina District. This seismic double whammy was bad enough, but it became much worse when combined with a fatal mistake made by the city's forefathers. 100 years ago, this land didn't exist. As the Bay Area rapidly expanded, stretches of ocean became beachfront property. The shallow edges of the bay were filled in with sand and debris.
The difficulty is these very fine and clean sands. When an earthquake occurs and you start shaking them, there's really nothing binding the sand together. It becomes actually a liquid.
Liquefaction is a deadly side effect of many large earthquakes. As solid ground turns to liquid, roads are destroyed, buildings topple, and underground pipes rupture. Liquefaction severed a gas main in the marina, igniting an inferno. The total cost of the quake was huge. 63 people died, 4,000 were injured, and 20,000 structures were damaged or destroyed. For seismologists, the 6.9 Loma Prieta quake was a brutal wake-up call. They were surprised by the reflection of seismic waves that struck the Marina District and Oakland.
With each earthquake, you have things that you didn't predict before. Every earthquake is in fact a learning experience.
But the 1989 Loma Prieta quake was not the worst to strike San Francisco. The same side effects of liquefaction and fire killed thousands when a much bigger earthquake struck, destroying most of the city by the bay.
Around the turn of the century, San Francisco was actually the premier city on the west coast of the United States.
The city featured luxury hotels and modern high-rise buildings. But in 1906, many came crashing down.
The earthquake occurred about 5:12 in the morning on April 18th. And when it occurred, it essentially occurred without warning.
A loud roar jolted thousands out of their beds. Seconds later, a giant shockwave hit the city, shaking buildings to their foundations. The West Coast's economic and architectural center lay in ruins. At the time, seismology was in its infancy, and the quake's cause was not well understood. We now know the city was caught in the middle of an ancient battle between the Pacific and North American tectonic plates, an infamous war zone called the San Andreas Fault. These mighty slabs of crust are scraping past each other directly beneath San Francisco. When sections become locked together, enormous pressure builds up and is released as a strike-slip earthquake. In 1906, 435 kilometers of the fault ruptured. A magnitude 7.8 quake released 8 times more energy than the 1989 event. The first and fastest waves released by any earthquake are primary or P waves. They act like a sonic boom, shaking the ground and rattling windows. A few seconds behind are the secondary or S waves. These carry most of the earthquake's energy and are the most destructive kind of seismic wave. In San Francisco, the S waves tore huge gashes in the earth and ripped apart building foundations like paper. But it was another side effect of the earthquake that sealed the city's fate. Liquefaction of the ground severed gas and water mains, and San Francisco began to burn. Without a water supply, the fire department stood by helpless as the city burned to the ground.
The descriptions of the fire they actually refer to this as a firestorm. And in a firestorm, the heat is so intense that it actually sucks in air.
The fire raged for 3 days, incinerating 10 square kilometers, destroying more than 28,000 buildings and leaving 250,000 residents homeless. More than 3,000 people were killed. The 1906 event proved that an earthquake's complex side effects can be more devastating than the quake itself. 80 years later, a bigger earthquake crippled a city 45 times larger than San Francisco. The key culprits, a totally different seismic side effect combined with disastrous city planning. But even that quake is dwarfed by a potential megaquake, an event of enormous power and consequence. The San Francisco earthquakes of 1906 and 1989 showed how reflection and liquefaction can have tragic consequences. In 1985, one of the largest cities in the world was crippled by an earthquake with even stranger and more unpredictable effects. It proved that where you build a city is as important as how you build it. Mexico City is one of the world's largest cities, with a current population of more than 20 million. The metropolis sprawls across a mountain valley in the center of Mexico. It's a city of non-stop activity, its massive population busy day and night. On September 19, 1985, dawn breaks on a typical autumn morning. Millions of people face the new day. Suddenly, the earth begins to writhe and buckle. A magnitude 8 earthquake strikes the city. The epicenter is off Mexico's west coast. It unleashes 6 times more destructive energy than the 1906 San Francisco quake. Hundreds of multi-storied buildings disintegrate into rubble. Thousands of others are severely damaged.
I didn't know what was happening. Your mind is racing 1,000 miles per hour. You don't know if you're already dead.
The city struggles to cope as phone and electricity lines are severed, emergency services overwhelmed, and millions left to fend for themselves. 3 of the city's largest hospitals are severely damaged, adding to the chaos and casualties. One of the most horrific scenes is at the Nuevo Leon, a 15-story apartment building. Of the 1,800 people who lived here, more than 600 were killed. Cuauhtémoc Abarca is a stunned witness as the Nuevo Leon falls victim to the earthquake's rage.
I recall it like a nightmare because this huge structure, so solid for us, in those moments it was collapsing, like if it was made of paper, like a model that an invisible hand was pushing down.
Cuauhtémoc and dozens of his neighbors rush to the demolished apartment building and with their bare hands begin a desperate struggle to rescue survivors.
There was a survivor, he was trapped by the debris. We couldn't move the concrete above him. It was so heavy. I was holding the right hand of this man, trying to encourage him. He was complaining, "This is so painful, it hurts." And he died.
The death toll is estimated at anywhere between 9 and 35,000. The true number may never be known. Why was this mighty city victim to such devastation? Mexico City is in the center of the country, hundreds of kilometers away from the earthquake's epicenter. And why were some areas practically annihilated while others were left untouched? For seismologists like Sina Lomnitz, this disaster would change their understanding of seismic waves.
There are various surprising factors that intervened to cause this particular earthquake to be a disaster.
The quake was triggered by movements of the Cocos Plate, which collides with the North American Plate off Mexico's west coast. Unlike the San Andreas Fault, where 2 plates are sliding past each other, Mexico is the scene of a tectonic head-on collision called a subduction zone. Normally, one plate slides smoothly under the other, but when a section becomes stuck, enormous pressure builds up in the rock. On that fateful morning, the pressure finally becomes too much. A section of the Cocos subduction zone rips apart, blasting a massive shockwave of seismic energy towards Mexico at thousands of kilometers per hour. During most earthquakes, the greatest damage occurs close to the epicenter. This one is different. Coastal areas suffer some significant damage. But Mexico City, located 322 kilometers inland, bears the biggest brunt of the earthquake. Bizarrely, most of the city is barely damaged, while small specific areas are almost completely destroyed. Buildings between 6 and 15 stories high suffer the most. Shorter and taller structures in the same block survive virtually unscathed. To solve the perplexing mysteries, Lomnitz and his colleagues searched directly beneath their feet.
Mexico City has a rather unusual location for a large city.
700 years ago, what today is Mexico City was a lake. The Aztecs built their capital city, Tenochtitlan, on an island in the middle of the lake. It was a massive complex of canals and causeways, with a structure as complex as any European city at the time. When the Spanish conquistadors captured and totally destroyed Tenochtitlan, they filled in the lake and constructed their own city directly on top of it. Centuries later, this turned out to be a very bad idea.
The sedimentary layer on which the downtown area is built is a layer of very soft clay. It's practically a jelly. It's almost water.
This ancient lake bed holds the key to the earthquake's strangely selective damage patterns.
Over the first 3 days after the earthquake, we realized that severe damage, structural damage, had only occurred on the former lake area.
The layer of soft lake bed was not just unstable, it acted like a seismic amplifier, trapping seismic waves and actually boosting their strength. Just like jelly will keep wobbling long after you shake it, the layer of mud under Mexico City continued to shake for 4 minutes after the earthquake.
This is the major cause of the disaster.
But that didn't solve the mystery of why buildings between 6 and 15 stories suffered the most damage. The answer came in the form of another destructive combination of seismic waves and loose sediments, a phenomenon known as resonance.
Every object has a certain frequency that makes it resonate.
If a singer hits the right note, they can shatter a glass just by subjecting it to its unique resonant frequency. Even a large object like a high-rise building can resonate. Depending on its size and structure, there is one energy frequency that will make it vibrate. By incredibly bad luck, the seismic waves trapped and amplified by the layer of mud under Mexico City were exactly the right frequency to make 6 to 15-story buildings resonate. The buildings began to vibrate, shaking themselves to pieces. Others smashed into their neighbors like battering rams. These freak circumstances doomed Mexico City. Many important facilities such as hospitals and schools were in the fatal size range singled out by the earthquake's fury. The Mexico City quake was a tragic example of the dangers of building on soft or reclaimed land. The unstable soils amplified the quake's effects and unleashed complex and deadly patterns of resonance. Today, buildings cannot be constructed on the unstable lakebed. Building codes and civil emergency plans are enforced to help prevent future disaster. The people of Mexico City know they're at risk from earthquakes, but millions of others live in striking distance of rare, mysterious quakes and don't even know it. And we're moving closer to an even bigger quake, a potential scenario that will combine liquefaction, fire, and other deadly side effects in a brutal mega disaster. San Francisco and Mexico City both fell victim to earthquakes spawned by the volatile boundaries between tectonic plates. Half the world's large cities are within striking distance of major faults like this, but the other half are not necessarily out of danger. There is a totally different type of earthquake. These rare rogue events strike seemingly from nowhere, ravaging areas thought to be immune to earthquakes. January 26 is India's Independence Day. But in 2001, the celebrations are forgotten when a massive earthquake strikes the western province of Gujarat. The 7.7 quake destroys the historic city of Bhuj, along with many other nearby towns and cities. 20,000 people are killed and 1 million homes lost or damaged. 200 villages are wiped from the map. Paul Bowden is a Memphis, Tennessee-based seismologist who traveled to India to study the quake.
What we saw was an immense amount of devastation. The human toll was incredible. It was a horrible place to actually be doing the work that we had to do.
For scientists like Bowden, the most stunning aspect of the quake is not the scale of the damage, but the fact that it occurred at all. According to the theory of plate tectonics, this earthquake should not have happened. Central Asia is no stranger to deadly quakes. Over 1 billion people live close to a massive tectonic collision as the Indian plate plows head-on into the rest of Asia. The Himalayas, the largest continental mountain range on Earth, are the crumpled wreckage of this collision. This volatile plate boundary has spawned numerous deadly earthquakes. The 2005 Kashmir quake killed almost 80,000 people in Pakistan and northern India. It was magnitude 7.6, not huge, but powerful enough to flatten hundreds of thousands of buildings. But Bhuj is 200 kilometers away from the dangerous Himalayan plate boundary. Large earthquakes shouldn't happen here.
But there's these rogue 5% that happen away from plate boundaries. And we don't have a very good understanding of what drives these kind of earthquakes.
These mysterious rogue disasters are called intraplate quakes. The 2001 Bhuj earthquake was an important opportunity to study one of these rare events. But Bowden and his team had a more urgent reason to travel from Memphis to India. The largest intraplate earthquakes in history happened right in their own backyard. In the winter of late 1811 and early 1812, the Midwest of the United States was torn apart by a swarm of massive earthquakes. They were probably bigger than any quake to hit California and are named after an ordinary town with an extraordinary secret, New Madrid. The magnitude of each can only be estimated since seismic recording instruments didn't exist, but there is no doubt they were huge. The first, estimated at magnitude 8, hits on the 16th of December, 1811. Houses and buildings are torn apart, entire forests are wiped out. Enormous cracks split and tear the earth. The placid Mississippi becomes a raging torrent of rapids and waterfalls. But this was only the beginning. A month later, another giant quake, estimated at magnitude 8, tears the frontier town of New Madrid, Missouri, to pieces. 2 weeks after that, a third magnitude 8 quake strikes. Over the next 2 months, almost 2,000 smaller tremors strike. The effects are felt throughout the entire eastern half of the United States.
In New Madrid, in the middle of the plate, to have a large earthquake, a huge earthquake, is astounding. And then to follow it up with 2 other events that were as large or larger, just incredible.
This incredible series of earthquakes seems to have come from nowhere. This is the flat, stable center of the North American plate. It's supposed to be safe from large earthquakes. Reelfoot Lake, 24 kilometers from New Madrid, is famous for its fishing. But seismologist Roy Van Arsdale hasn't come for the largemouth bass. For him, Reelfoot holds the key to unlocking the mystery of the New Madrid quakes. 200 years ago, this lake didn't exist.
Well, this serene swamp and lake area was rocked severely during the winter of 1811-1812 in a series of 3 giant earthquakes. It was the 3rd one in March that is responsible for the formation of this lake.
Reelfoot Lake's peaceful appearance is deceptive. Beneath its calm waters, scientists have made an earth-shattering discovery.
There's microseismic activity, meaning little earthquakes are occurring all the time out here. So there are seismometers planted in the landscape around us, measuring, recording these earthquakes.
Deep under Reelfoot Lake and New Madrid is a mysterious fault system that spawned the huge earthquakes of 1811-1812. It continues to generate small earthquakes today. But this discovery raises even more questions. If the New Madrid fault is not a plate boundary, then what is it? The answer to that lies far away in Ethiopia. This is part of Asia and Africa's Great Rift Valley, a fault system that stretches 4,800 kilometers from northern Syria to Mozambique. The earth here is splitting apart and bleeding molten rock. A tectonic plate is being torn in half and pushed apart. A process called rifting. 500 million years ago, this almost happened in the peaceful plains of the Midwest. A surge of magma spewed up from the molten interior of the Earth, eating through the crust beneath the ancient Midwest. But before the plate was completely split, the magma retreated, leaving behind vast cracks in the Earth's crust. As pressure builds up on this fault system, it's released as massive earthquakes. A similar failed rift has been found near the city of Bhuj in India. The buried rifts under Bhuj and New Madrid solved part of the mystery. But there are still many things scientists don't understand about intraplate earthquakes. They have no idea what triggers these rogue disasters or where they will strike next.
We really don't have a good working model for what drives these intraplate earthquakes. This is still quite the mystery in seismology, geology that a number of us are working on, and we just don't have an answer to that right now.
In 1811 and 1812, the New Madrid earthquakes struck sparsely populated areas. Today, millions of people living in cities like St. Louis and Memphis are within striking distance of the New Madrid fault system. If it wakes again, the human and economic toll will be devastating.
It would be foolish to think that it couldn't happen again, that it's over. There's no scientific evidence that whatever is giving rise to these earthquakes has gone away.
The New Madrid quakes were the largest intraplate earthquakes in history, but they pale in comparison to a massive tectonic rupture that ripped through Chile, producing the largest earthquake on record. And even that catastrophe is not the worst-case scenario. Experts believe a giant earthquake lies in wait, one whose shockwaves will ravage a nation and shake the entire planet. There is one earthquake that towers over all others, one so massive it changed the shape of a nation and killed people half a world away. This is a staggering event that rates as the largest on record. In the small Chilean town of Maullín, life is quiet and simple. Its 1,500 residents depend on the sea and the soil to survive. But in 1960, both elements conspired to decimate this peaceful place. Juana Lopez was 8 months pregnant when her world was torn to pieces.
I was at my sister's house and felt a movement. Immediately I realized it was an earthquake.
Nelly Gallardo was also caught by the earthquake's violence.
We couldn't stand up. We had to sit down and hold to our fins. But the fins were moving like this. Then the earth started to open.
But the shaking in Maujin is just the beginning. A massive catastrophe is spreading across Chile, killing thousands and shaking the entire nation to its core. 161 kilometers off the Chilean coast, the small, dense Nazca Plate slams into the much larger and lighter South American plate, creating a subduction zone. This is far more dangerous than the one that affected Mexico in 1985, because here it runs the entire length of the continent. On May 22, 1960, the Nazca subduction zone spawns the largest earthquake ever measured by scientists, a massive magnitude 9.5. The amount of energy unleashed is equal to 32 billion tons of TNT, or more than 2 million Hiroshima bombs. The intense seismic waves tear apart cities caught in their path. Buildings topple, the ground turns to liquid, landslides sweep down mountain slopes, and cliff fronts collapse into the ocean. The city of Valdivia, close to the epicenter of the quake, is besieged. Almost half the city is reduced to rubble. But this is just the beginning. The fault rupture sets in motion a chain of events that ruins lives for generations and permanently scars the landscape. Today, Valdivia is once again a thriving city, a strategically important point at the meeting of three rivers. But take a closer look, and there are secrets beneath the water. Mysterious streets that plunge into nowhere, drowned foundations, and ghost-like ruins along the river's banks. The 1960 earthquake did far more than shake things up. It forever changed the shape of the land itself. This ruined landscape is the victim of a side effect of the massive Chilean earthquake called subsidence. Valdivia's fate was sealed hundreds of years before the quake. For centuries, pressure built up along the boundary of the two great tectonic plates off Chile's coast. The South American plate began to slowly bulge upwards under the strain. When the fault ruptured in 1960, the strain was released on the South American plate. It snapped back to its natural shape, lowering a vast swath of land 2.5 meters. For the people of Valdivia, this is a disaster that will last for generations.
Most of this area before the 1960 earthquake used to be pastures, high-quality pastures. The ground dropped 2 meters down, and now the tides cover every day this land. So there was a huge damage on the economy of these people here because they lost the soil, the better soil of the area.
Over 200,000 square kilometers of Chile's coast subsided after the earthquake. But incredibly, even this was not the most deadly part of the day.
They said we need to be prepared because the sea is coming in. The tsunami is coming, and we have to climb up the hill.
Just 15 minutes after the massive quake, a series of giant earthquake-generated tsunami waves slam into the coast. Some are 18 meters high. From her vantage point on the hill above Maujin, Juana watches as half the town is washed away.
The waves were coming in, trying to imprison us. We heard another wave coming, starting to move the houses that were on the shore, making them hit one another. It was a terrific noise, a noise that scared us.
But Nelly Gallardo had no time to get to safety. She was caught by the full fury of the waves.
As the wave was advancing, trees and other things were disappearing in its path. I climbed up into some trees, but when the second wave came, the trees were not strong enough to hold us. So I jumped onto a log and tried to hold on and keep my face out of water. Then a boy climbed onto the log too.
122 people from Maujin drowned that night, but somehow Nelly survived. The giant waves wreaked havoc far beyond Chile. They radiated out from the fault rupture, striking other unsuspecting Pacific locations. 15 hours after the earthquake struck, the tsunami reached Hawaii. The port city of Hilo was devastated and 61 lives lost. 7 hours later, the tsunami hit Japan, killing 122 people. The Philippines and the west coast of the United States also felt the waves of destruction that day. When it was all over, the great Chilean earthquake killed 2,000 and left 2 million homeless. It remains the largest earthquake on record. But records were made to be broken. Scientists believe another giant earthquake lies in Chile's future, one that could be much, much worse. The evidence pointing towards a mega disaster lies on a remote section of coastline in southern Chile. This was once a big forest until the 1960 earthquake and tsunami devastated the area and left only twisted stumps. To the trained eyes of geologist Marco Cisternas, this deserted beach holds vital clues to Chile's seismic future.
The 1960 event wasn't a unique event. Although it was a giant, it wasn't unique. In this outcrop, you can see there is a buried soil here. This is 1960 soil covered by a tsunami sand layer here. And below that, you can find another soil corresponding to the 1575 earthquake.
Along this coast, there is evidence of another dozen earthquakes that ravaged the area in the last 2,000 years.
So it is certain that in the future, another earthquake, giant earthquake, is going to strike central Chile.
When it strikes, it will be an ultimate disaster, an event that will cripple the country and send shockwaves around the entire planet. In 1960, the biggest earthquake ever recorded rocked Chile. Thousands died, and the landscape of the country changed forever. But scientists believe a far more destructive quake could be on Chile's horizon. Don Windeler is an expert in modeling disasters of the future. Using data from the giant 1960 quake and input from some of the world's leading seismologists, Windeler and his colleagues have created sophisticated models of potential earthquakes in Chile, including the ultimate worst-case scenario.
There's no stopping the Nazca Plate from going underneath South America. We will continue to see large events over time in Chile. It's just a fact of life.
The massive 1960 earthquake struck in the center of the country, where the population was relatively light. But if the Nazca Fault ruptured further north, near to Chile's largest cities, a major catastrophe would result.
We're going to expect to see a lot more economic loss, a lot more casualties resulting from this event.
Valparaiso is one of Chile's major ports and home to its navy and houses of parliament. The city sits in an amphitheater facing the ocean. Most of its 270,000 inhabitants live on the steep hills above. and are carried to their homes by unique machines called funiculars. Just up the coast from Valparaiso is the tourist resort of Viña del Mar, famous for its beaches and luxury hotels. Valparaiso and Viña del Mar are both part of Chile's most valuable stretch of land. If hit by a major earthquake, the nation would be ravaged.
Just that one area from Valparaiso across the country through Santiago metropolitan area contains over 50% of the property value for the country of Chile. And any kind of event that has significant, serious damage to that area is going to have repercussions to the economy of the country.
Windela's nightmarish scenario begins 27 kilometers under the earth and 80 kilometers off the coast in the collision zone between the Nazca and South American plates. A stress point snaps, starting a chain reaction. More than 1,400 kilometers of the subduction zone rip open like a zipper. Massive seismic shock waves spread from the rupturing rock. The primary waves speed out at 29,000 kilometers per hour. The arrival of the P waves in Valparaiso feels like a long sonic boom. Windows and buildings shudder. Some of the P waves shoot up into the atmosphere, emitting a frightening roar. The secondary waves follow, carrying most of the earthquake's energy. Some surface waves shake the ground from side to side, twisting railway lines and shattering concrete structures. Buildings are shaken from their foundations. Unstable areas of the cliffs surrounding Valparaiso collapse, taking many buildings with them. Below, in the port, sediments amplify the seismic energy, prolonging the shaking and the destruction. Liquefaction ruptures gas mains, water pipes, and vital communication links. In addition to the deadly seismic waves, the earthquake rupture releases pressure on the South American plate. It pushes forward and flattens. Areas of the coast sink 2 meters. Entire structures collapse and flooding is rampant. Fires caused by broken gas mains rage out of control. As the city lies paralyzed and in ruins, the biggest killer of all is about to strike. As the South American plate is released and flicks upwards, it pushes up an enormous wave of water 967 kilometers long. Gravity quickly pushes it back, creating a massive wave, a tsunami. One side of the wave rushes towards the coast of Chile. It takes just 10 minutes to reach Viña del Mar. It hits the already besieged city with a 12-meter wall of ocean that smashes across the city. Thousands more lose their lives. The city is devastated. But the giant earthquake's deadly reach extends far beyond Chile. The same tsunami that pulverized Viña del Mar speeds across the Pacific for thousands of kilometers. Hours after the quake, huge waves strike New Zealand, Hawaii, and Japan. The west coast of the USA and the Philippines will also be hard hit. Chile's mega earthquake is now a global disaster.
Taking the 1960 earthquake, this massive magnitude 9.5, and moving it closer to Valparaiso and Santiago is something that's not likely to happen anytime in the near future. It's highly unlikely. But at the same time, given what we know about Chile's tectonics and its past history, it's very difficult to exclude that from saying that it can't occur.
Chile's mega disaster will probably not happen within our lifetimes, but scientists believe a major city will be struck by a devastating earthquake.
We're setting ourselves up for larger catastrophes should an event occur near one of those cities.
Experts agree that while it's impossible to prevent an earthquake, it is possible to prepare for one.
There are really many things we don't know about earthquakes, but we do know one thing. The way to avoid disasters is to be prepared for them. When there is no surprise, there is no disaster.
Danger is that if we're not prepared, if we don't prepare our cities for the hazard that exists, there'll be hell to pay.
Half the world's population now lives in cities, placing hundreds of millions within striking distance of an earthquake. For all of them, the clock continues to tick on these giant underground time bombs.